Good afternoon once again, and welcome. Before we start with today's session, which is supposed to be the last, but of course there are other arrangements. I would want to find out if there is anything that happened yesterday of which you didn't understand, with the exception of what you requested for. Maybe we'll go in through the codes once more. Apart from that, is there anything you didn't understand of which you may want to bring out for us to discuss or clarify more? Anything? Okay, should we start with today's on?
Yes, please, we can start.
Okay, so since we are okay with this one, then I'm going to switch to the social network analysis because this is exactly what we did yesterday. I wanted to find out if we have some kind of comments or questions regarding what we did yesterday. But if there isn't any, then I'll close this one and open. Okay. All right. So we don't have any question from yesterday's session. So today we are going to pick up with social network analysis. Okay. Are you good on that? Can you hear me? I don't know.
Yes, we can hear you. We can see your screen as well.
Okay. Okay, that's fine. So I think I shared this materials here with you. Do you have any idea what maybe social network analysis is all about, or probably network analysis? Is this something you've heard before, or it's the first time you're hearing this?
First time.
Oh, first time you're hearing social network analysis. Okay, that's interesting. Any other person? I think we have a lot of people here. We have Abigail. Abigail. Abigail doesn't want to say anything, but she'll speak today. Yes. You've heard anything social network analysis or maybe network analysis?
No, please.
Oh wow, that's
No.
interesting. What about we have let me see, Christy. I think it's been a while. Christy. Hello, Christy. Is she there? Hello. Oh, Christy is not around. Okay. Caleb, have you heard anything about social network analysis or maybe network analysis? Oh, he's also not here. All right. So I'm going to make a simple assumption that maybe this is the first time you are hearing social network analysis, and we are going to get down into it to even understand the theoretical aspect of it, to know when and how to even apply it to solve problems. Okay. Now, everything around us is seen as a network. Okay, and I'm going to explain that in a moment. and then for you to understand why we are saying almost everything around us is a network. Okay, right. But then, what we understand it from that perspective, we now come to the social aspect of this thing, so that we can look at network analysis from a social perspective. Okay. So this is a network. Okay. Whatever thing you see over here is a network. It's about a bunch of actors and the relationship between them. So when I say actors, I'm talking about these big dots. And these big dots can represent anything. It can be human beings, for example, what we have here. It can be any family members. It can be your course mates. It can be those you work with, your colleagues at the workplace. It can be your social media friends, like everything. Okay, so what we are interested in here is that we have actors, okay, object of interest, and then the relationship between those objects. That's what we are looking at over here. So this can be something like social media. So this could be me, and I'm friends with this person. This person here is also friends with this. This one here is also friends with this. Then the issue is, if I want to get in touch with this person, how do I do that? Maybe I know this person. This also knows someone who knows him. So in effect, we can have some kind of relationship between myself and this one, maybe indirectly, because once I know you and you also know someone, indirectly, I know that person. So if I need information, I can go through you and then you get that kind of information for me. Okay. So this is just from a pictorial view how network is structured. Okay. Now, to understand a network, we want to come from a systems perspective. Okay. Now, coming from a system perspective is going to help you understand whatever thing is happening here. Now, if we put everything here together, we are going to call it a system. And that's why we want to come from a system perspective. Okay. Now, a system, you guys have heard about system before. What do you think a system is all about? You've heard about system, you've heard about systems theory, a lot of things. And in fact, you even did that is it integrated science or something? Okay, like nervous system, those kind of things. Do you have any idea what a system is all about?
So, first, the system is basically when multiple individual units come together to perform a singular function. That's what's usually referred to as a system.
Okay, yeah. So I'm going to pick your definition or from your perspective to say that system is nothing but when we have a given objective, okay, like one objective, but then we have a lot of components that are coming together to make that objective a reality. That is what we call system. So, for example, you can pick a vehicle, maybe a car. Okay, we have one comment here. Oh, someone is having a problem with their network. Um, we can pick a car as an example. For a car to move, honestly, there are a lot of things that have to go on in there. We have some engine, we have this, we have some cables, we have some starter, we have this. Now, each one of them is performing a role to allow the car to move. Now, the role that the engine is playing is different from the role maybe some kind of fan belt is also playing. That is also different from what the starter is playing. But you come to realize that all of these elements, they are independent. Okay, let me call it that way. They are independent because we can take the starter out as an independent element. We can also take maybe the fan belt or however it's called as an independent element. But then when we put them together to make the car functional, we say that all of these independent parts are connected. They cease to be independent. They are now relying on each other. Now, when you hit this button, this will trigger this, and then allow the system to function, or maybe the entire goal to be achieved. So if a car is supposed to move, then it means that a button has been clicked, an engine has been started, some gears has been changed before the car moves. So all of these components coming together to work to make the car move is what we are calling a system. So, for example, a company can be seen as a system because the company is made up of a lot of human beings plus some objects like human beings and others are not human. But for example, the human being and the computer. Now, when the human being interacts with the computer to get the job done, then we are saying that we are seeing the company here as a system. And the goal of this system here is to get someone's job done. And the human being came in, the computer assisted, someone also brought some kind of ideas. Put together is what made the job completed. Okay. So we can see that as a system. We can see something like in science, digestive system, you put food in your mouth, it has to go through like a whole bunch of processes to get the food digested. Okay. Every single aspect of it is playing its role to get the food digested. A family is also a system. We have the father, the mother, maybe siblings, all of those things. Now there's a relationship between them. And when we put all of them together, they are making the family a whole. And that is what we refer to as a system. So going forward, I'm going to explain something to you from a different perspective so that you understand it. And that is this guy here. It's called systems thinking. Remember what we said about system. We said system is just interconnected parts or bunch of elements that are connected together, and each one is playing its role to make or to move the objective forward or help us achieve the goal. Okay. Now, when we talk about systems thinking, it's more of let's say, okay, let me come from this perspective. Assuming you have let's say maize farm, okay, and you get to realize that we have some, I don't know which one should I use, which one should I use, which one should I use? I'm really thinking about a very good example that I can that can explain this one. Then I know from your perspective, okay, what do you think? And that is going to define systems thinking here and then how we can put it to work. Okay. All right. So let's say that you have maize farm and then you realize that there are some pests that are destroying maybe your maize farm. When this gets to your attention, what would you want to do? Yeah, hello. Yeah. Yeah, good afternoon. You missed my call. Sorry. So I was asking, you just found out that you have some maize farm and then there are some pests destroying it. What would you want to do?
And first, you spray the farm with pesticide.
So you just have to spray the farm with some kind of pesticide and you are done. Okay. Do you think spraying the farm is going to solve the problem? You see, upon first thought, that is what comes in mind. We have these pests that are destroying your maize, so you go ahead and maybe spray it and then kill them. But are you also aware that we have something like a grass cutter, those kind of animals that also eat maize and things like that? Are you aware?
Yes, Pastor.
Okay, so the idea of systems thinking is that, okay, instead of you jumping into conclusion to say that, oh, these pests are destroying your maize, so why don't I spray and then kill them? System thinking is saying that no, don't just go ahead and spray to kill them. Can you understand that if I spray all of these things and kill them, what are the chances that there is another thing that can also come and destroy it? So an example is maybe those pests also feed on, let's say, grass cutter. You know, if you have grass cutter in your maize farm, you are dead. Give them 2 days and everything is gone. But maybe the pests are not going to destroy it in that rate. It's like very slow. So if you spray all of these pests, which the grass cutters are afraid of course, these pests are going to die. But when they die, then the grass cutter will get in there to destroy all of your maize farm. So systems thinking is saying that no, instead of me looking at the face value to destroy what is actually happening right now, let me dig deeper to find the root cause of this whole issue. And once I get the root cause, I'm able to resolve the issue. Do you understand that? Okay, so this is how Robert put it. It says that if a factory is torn down, but the rationality which produced it is left standing, then that rationality will simply produce another factory. Do you understand that statement? So if something is happening, okay, if something is happening, and we don't go down to look at the root cause of it, but we decide to destroy what is happening right now. Now, if the reason for that thing happening still stands, that thing will happen again. You understand? So let's say in Ghana, we have a lot of youth rising up against maybe leaders. They are fighting them, ABC. And what the leaders were able to do was to just maybe come up to give them maybe coke. And now all of the youth are so calm. Everybody is cool. Now, the reason why the youth stood up to fight the leaders were not, in fact, honestly, it's not because they want coke. Okay, so you trying to use the coke is like you are managing them for the meantime. But what is driving them to come and then fight is still there. Okay, and going forward, that same thing will drive them to come and fight the leaders again. So it is about the leaders to understand the root cause. What is causing this youth to rise against us? Then they should tackle the issue from that place. So that's what this guy is saying, that if you have a factory, okay, and that factory is torn down, but then what actually produced that factory is still there, then that same thing will produce that factory again. So build the factory, let it stand, go and collapse all of the factory. But if you have the exact same formula or the tools that built up that factory, still there, people are going to use that same thing to build factories again, okay? So if a revolution destroys a government, but the systematic patterns of thought that produce that government are left intact, then those patterns will repeat themselves. So that is what someone is saying. From another angle, we have another person also making an argument saying that managers are not confronted with problems that are independent of each other, but with dynamic situations that consist of complex systems of changing problems that interact with each other. Okay, so it's like managers are actually managing messes. Okay, so if there is a problem in the organization and you tend to just look at the problem and then resolve it just like that without looking at the root cause, then of course we are saying that whatever problem is happening right now, it's coming from a complex system. The guy who brought the fight, on any wife and he's coming to pour that anger on maybe the junior staff. So you trying to bring maybe this person and the junior staff together to say that, hey, we don't fight here, ABC. It's not going to solve the problem because the wife is at home, will cause another confusion, and the man will come and then put the blame on maybe the junior staff again. A moment. Yeah, brother. Oh, okay. But no, I will. No. Oh, okay. All right. But no class, isn't it? Okay, so if this worker comes and then begins to put all of the blames on, let's say, or have issues with the junior staff, of course you are going to resolve that. But then the reason why this problem actually came up was because of the manager or that leader's wife. Okay, so if you don't get to the root to understand what actually is driving this anger or whatever is driving this particular problem, you see that you resolve the issue between the junior staff and the senior staff and the junior staff. But then the senior staff will come back from the house angry and then put things in the wrong place again. Okay. So I don't know if you understand the argument behind systems thinking.
Yes,
Yes, it makes sense.
Okay, sure. So it's more like what you're seeing is just a tip of the iceberg, something like that kind of thing. A lot of things are hidden, and that is what we need to unearth to understand what is actually causing it. And once we understand that, the issue can be resolved. So this is we are taking it from this side to the network perspective of thinking. Once you understand that every single thing is a system, okay, so this is happening because there is something causing it. Like the root cause is ABC. Once you know the root cause, you know that there is a relationship between that root cause and another organ or part of it, and that part is actually driving whatever problem we are seeing today. So it's about us going back, okay, going back to the root cause to address that. So that is for systems thinking. Now look at this. Traditional analysis actually focus on separating the individual pieces of what is being studied. Okay, but in the area of systems thinking, it's a bit different. We try to look at the structural components and then how all of these components are interacting, okay, to make up a whole system. Okay, so this structural component actually creates a network, okay, and this network you're trying to manage it as a challenge. Now, for example, if I pick this engine, you see the first example was about the entire vehicle. We said it has an engine, it has this, it has this. Now, when I pick the engine alone is also a system on its own. Okay, so it's more like we have systems of systems. Okay, it's like systems of systems, and all of these systems interacting. All of these individual systems interacting brings us to the idea of networks because there is some kind of dependency. Now, you look at this engine here. Okay, this engine is a system made up of a lot of components. You see some kind of belt over here. This is one component. We have these two guys that are turning. I don't really know what they are. We have these guys down here. These are also individual components. But for this guy here to move the car, it's maybe dependent on this guy here. Okay. So if you try to drive the car and the car is not moving, it's probably because this guy here is spoiled. So you have to come and change this. So each one of them is dependent on each other to allow the system to work. So when there is an issue, you need to understand the root cause, go down there to fix it. Okay. That is what system thinking is all about. So this is going to bring us to the idea of a network. So we're saying that a network is a collection of interconnected elements or entities that are linked together through relationships. Okay. So like I said, in this space, we are looking at actors or entities or elements and the relationship between them. Now, the relationship between them from a social perspective, we can say the relationship between myself and you is maybe teacher-student relationship. Or it may be that I know you, you also know me. Or it may be that we are maybe we fellowship in the same church. We do this. Any relationship at all is can be considered. Okay. Now, these entities actually represent people. It can also be computers. It can be cities. So if you want to come out with a network structure, it can be a network of anything at all. Okay. It can be a network of health facilities in Ghana. That this health facility, there's one facility in Kumasi, another facility in Accra, and these facilities are connected. because this one takes drag from this one. That can be a network. Okay, it can also be cities. It can be anything of interest. Okay. Now, what is going to make it a network is not just the independent component, but then the relationship existing between them is what creates some of these relationships. Okay, so we're trying to understand the formation and the structure of this working system and how they all depend on each other. Okay, it's very important. Now we have this individual actor. We understand how it operates and everything about it. We know the relationship between them. It is now about time we understood how that structure even came to be. Okay, how did I get to know you? How did you get to know me? How did we become friends? We understanding how this thing even came to be is very important. Okay, so in your organization as an HR practitioner, you come to realize that, you see, at the workplace, informally, we have some leader. I say your employee be or kasa obi. Have you realized that?
Yes,
He's not
Pastor.
the manager. He's not the manager. He's nothing. But I say he's the boss over there. I say they are all colleagues, but kasa obi. Now the point is going to be you understanding how this thing came to be. Say that whenever there is a new worker, be no so be joining that team, no, that person sees him as maybe some kind of leader. Be when we know that he is not the leader. So how is that structure coming up? What happened? What do they see in that person? It is up to you from this perspective to dig deeper to understand what is happening. Okay, so it is very important that we understand how these structures are formed and then how they all depend on each other. Okay, and that is going to be our focus. Okay, now to build a network, we are saying that we have two main things. One is the entity, and the one is the connection or the relationship between them. And you remember I mentioned that the entity are the actors, and then these actors can be anything. It can be employees, it can be some maybe workers, it can be computers, it can be anything. And then the connection between them can be friendship, it can be conflict. Like if you want to come out with a network structure of maybe some kind of conflict in the country, you can now create the actors are going to be the various tribes. Like we have Ashanti, we have Nzema, we have Voltarians, we have this. Then you try to create a connection between these tribes. Like, okay, between Ashanti and Nzema, maybe there is a conflict. Between Nzema and maybe Ga, there is a conflict. Between this and that, there is a conflict. That also becomes a whole network. And we can study how or the structure and how it even came to be. We understanding what brought up about this whole thing. Once we understand it from the maybe the root cause, we can now seize it from that point, and there's not going to be any further conflict of that sort. Okay. All right. So the implication is that a network is just an aggregation of entities and the connection that exists between them. Okay. I think I've been repeating this one for quite some time. Okay. So an example is a family is a network that constitute individuals. Okay, in this case, the individuals or the family members are the entities, and they are related through some kind of ties, which is from a family. Okay, so that is the connection between them, and that is what makes a family a network. So if you have actors and you can't identify any kind of ties between them, there is no network. Okay, so a company is also a network containing or made up of individuals or workers. These workers become the entity and they are related through shared vision. Okay. So if this person and this person have got the same vision, that is the vision of the organization, then we can come out with a network to say that this is my company's network. All right. So this is a network of the royal family. Okay. So I think this image here has to be updated. Okay. So you can see these two people having coming down to maybe this generation. You understand? So this is what we are talking about as a network. There's a relationship between this and this. Okay. And if you pick this line, there's a relationship between this. Do you see coming down to even understand who can inherit or who cannot ABC. So this is a whole network, all right? And you can understand the kind of connection or relationship existing between this family, okay? So the question is, once we understand network, okay, everything we've been talking about is the network, the actor and the relationship between the actors. If you come to social network analysis, we are saying that it is the method for which we can examine or understand the structure, the features, and the patterns that exist within various networks. Okay, so we understand what systems is, or what a system is. We understand what systems thinking is all about. We understand what a network is. And the key thing here is that we have an actor and that we have a relationship between the actors. Now, how do we investigate this network to see how did this come up? Why is this that? Who is going to be the next connection? How do we do that? The method for which we can arrive to this conclusion is the social network analysis. Okay, so if I give you a network like this one, and I ask you to tell me what is your opinion about this particular network, of course you can look at it to see that, okay, this actor here is powerful because he's connected to a lot of actors over here. Probably that's what you can say. But if I ask you a question of how do you think this thing came about, and if this guy here is related to, let's say, you see this guy is related to this, but this guy is not related to this, then I ask you, what are the chances that this guy will get connected to this one? Okay? That also becomes a challenge on how you can conclude that, oh, there is a high possibility that this is going to get in touch with this. Now, these people used social, I don't know if it's the Americans or something, but they use social network analysis to do something very interesting. And they were using it to identify at the prison, okay? I think they use social network analysis in prisons to identify terrorist operations and some kind of gangs that are coming up over there. So it's very funny. Going forward, you come to understand how to employ social network analysis to create new kind of relationships, or sometimes to even destroy some kind of relationships when they need be. Okay, so we are going to explain that, and I'll bring up that story too. Okay. So a network can represent various types of interactions. It can be friendship. I know you, you know me, I know this person. In Tinkasisiano, let's say who knows or who has got the contact of, let's say, ex-president Ajekum Kufuor. Who has got his contact? Anybody? I know Obi any Kufuor number. Hey. Okay, let me calm down a bit. What about Kennedy Japan? What about Kennedy Japan number? Hey, I said one. So if I want to get in touch with Kennedy Japan, Obi any hobby me abwa. Philly? Mr. Felicia, who need Kennedy Japan number? Oh, why are you guys quiet? Anna. The issue is, so someone is saying we can ask from others outside this network. So you see the relevance of this network we are talking about. So basically, you know that if you know your network, that me, I know this guy, and this guy knows Kennedy Japan over here. So if I want to get to Kennedy Japan, I just have to speak to this person, and this guy can connect me to Kennedy Japan. So that's one of the benefits of this network thing we are doing. So right now, assuming there is someone here who knows Kennedy Japan, and I have something really important I want to tell Kennedy Japan, all I have to do is to go through you. And once I tell you, you know how to get him. That becomes much easier. Okay. And recently we did some research I think the last time I told you about it, the tracer studies, and as it turned out, the result was that most of our graduates, or the KNUST School of Business Supply Chain graduates who secured jobs, they did not secure the jobs because they were competent or something like that. Competent was a key factor, but that's not the reason why they got the job. They got the job because they knew someone, okay? But then they are able to sustain their job because they are competent. There are two different things. So we come to realize that these two things are really necessary. Okay, let me see if I can. Let me stop. I'm coming. I want to see if I can find this thing here for you guys so that I can appreciate document. Okay, script, find it. Okay. Okay, great. Yeah. So we came to find out that, of course, in the area of employment, people's social networks, like their friends and things like that, were helping them to get the job. Okay. But what was sustaining this job here was their skills. Okay. Their skills is what was helping them to sustain it. So if you are here, what you may want to pay attention to, or one of the things you may want to pay attention to, is going to be your social network, the kind of people you know, okay? And those you know, as that is how you can sometimes get there. Sometimes you won't get there because maybe you know how to do it, but you can get there because someone knows that you know how to do it. So if you don't know anyone, it becomes a challenge. So it is about time we paid attention to our network. And then, like I said, the network, it can be anything at all. You can construct network for any single thing. But the problem is that collecting data or how to construct this network is very tedious. Okay, I will explain that to you. It's very difficult. Okay. All right. So social network analysis, in this case, actually provide insight into how these relationships influence behavior, information diffusion, and overall system dynamics. If you know the kind of relationships that are being formed within the organization, then you understand how the system works and what can break your system and what can make it functional. If we're going forward, we have a lot of information in here to share with you for you to appreciate some of these things. All right. Okay. So we say that a social network analysis is better for understanding or answering some of these questions. Okay. Which actors are involved in a network? When you come to maybe you have a question you want to answer, and your question is like, who and who are the actors within this network? Then social network analysis is good. You can use SNA to address that kind of question. Then how are they linked? Once I've identified all of the actors in the network, like a class, I know the class, we have this person in the class, we have Christy, we have maybe Muslim, we have Josh, we have this person. SNA can help us identify all of these. Then the second thing is that it can help us understand how they are connected. Okay, Muslim is connected to this person just cosmate. This one is connected to the next person as maybe let's say steady mate. All of these things. Okay, we can also use it to understand how influential each actor is. Okay, just like the case of the prison, the study was like they were just looking at, I said, who is the gang leader over there, and they realized that this gang leader here can cause a lot of problems. So once they use social network analysis to identify who the leader is or who has got the power and is influential in within the space, they just lifted that person, took him out. Okay, they took him out. to a different kind of prison. So it's like we don't have any kind of leader in that prison again. Then the next thing they were doing was they were just observing how, or the structure or the processes through which a new leader will emerge. They were studying that, and they came to identify a particular pattern. If you want to be a leader, then you have to start to do ABC. Once they discovered that, getting a leader over there again is going to be difficult. Then SNA is also better to understand what the motivation of these actors are and how the network is even structured. Okay, and we have a lot of benefits. Okay, we have a lot of benefits to this one. Okay, if you tend to run SNA, it helps you to do a lot. Okay, for example, better informed project design. If you want to design your project and then you have an idea about all of the actors and the relationship between them, I think I can help you design it very well. In fact, we have all of these things here. I wouldn't want to go through one by one. But of course, if there is anything you don't understand in there, you may want to bring it up. Now we have some questions over here. These are not all of the questions, of course, but if you're looking at asking this kind of questions, then social network analysis as a methodology can help you to arrive at the answer. So a question like, how does information flow within an online community? And what are the key factors that influence the dissemination of the information? To answer this question, you need social network analysis as a methodology to do that. Because to understand information flow, you first have to identify all of the actors and who is actually taking the information out there and how does the information get out. Sometimes you come to realize that there's one key guy in the middle. Look at this. This is a network on its own. This is also a separate network. This is a separate network, and this is also a separate network. So if you want to look at how information is diffused within this structure, then you have to realize that, okay, this guy here, as a so he knows, he is knowledgeable, he knows everything. And whatever is happening here in Canaan here, it should remain in Canaan or wherever. But these people get to know. How did they get to know? All of these things, and these guys here are not connected to anybody here, but they are all connected to this guy. This guy is now becoming the compons, and he is now pushing the information out here. Do you understand that? So if you want to understand information flow or how information is flowing within a given space, then social network analysis is the best methodology for you. Then if you want to understand or answer the question of what are the patterns of collaboration and knowledge sharing among the employees within an organization, okay? So where can we buy and what join team way? Why? What is the pattern? Like what's happening? If you want to understand the pattern of this collaboration and how they even learn among themselves, okay? And how these patterns impact the quality of work, then social network analysis is good for you. And a question of what is the influence and impact of the communication network structure on decision-making process and organizational performance. Now, social network analysis is going to help. And if you want to know the role of interpersonal connections in shaping the spread of health-related behaviors or attitude, then social network is also important. Once you are going to identify actors and the relationship between them, you are good to go. And like we said, the relationship can be anything. It can be, I know you, you know me, I communicate with you, or I tell you things, you tell me something, flow of information, just anything at all related to relationships, okay? So we have all of these tools. If you have your data and then you want to perform a network analysis to understand the flow of information or everything within your network, or who are the leaders in the network, then you may want to use any of these tools. Okay? You can use R for that. You can use Python for that. All of these tools are there, but I'm used to Gephi. Okay, so Gephi is graphical user interface application that allows you to load your data, then it runs the analysis for you. You don't have to struggle a lot. Okay, So this is the Gephi guy I'm talking about. We have a lot of people using UCNet, Python, and then R as well. Okay. So we are now going to dig deeper into network structures, which forms the basis of social network analysis. Okay. So a network can either be bounded or unbounded. Okay. So we say that a network is bounded when we have an idea of the number of actors within the network. So for example, in a company, we know the number of employees we have. In a class, we know the number of students over there. Now, this is a bounded network. But we say that it is unbounded when it does not have a set of number, or like we don't have maybe an idea of membership within a network. Okay. All right. So for example, if we have a weekly meetup group with an open invitation, then this week we don't know the number of people that will come because we have an open invitation. We don't know whether someone will show up or not. That becomes an unbounded network. But in our case, we'll be focusing on network that is bounded. Okay. All right. So these are some of the objectives and questions for social network analysis. Okay. So SNA is driven by a set of research questions and objectives. Okay. And most of these activities are descriptive and then exploratory in nature. Then I think for the examples we've seen a lot, I'm going to pick just one of them. A question like, what organizations are formally connected to KNUST? In what ways do they contribute to KNUST's growth? And this is a question social network analysis can answer. First, you need to identify all of KNUST's partners. They become the actors. You need to understand the relationship between them. Okay. Once you understand the relationship, maybe they are sponsors, they are this, they are that. Once you understand this one, you also need to understand how each one of them is contributing to the growth of KNUST. And this is a social network analysis methodology for you. Okay. So SNA questions actually focus on central individuals, organizations within network. For example, who is the key actor within the network? There are some organizations there. We have some employees. When you sack them, like it won't work again. Do you see that? We have some jobs too. If this person here is not there, I say morale never form. I don't know if you've experienced that in your workplace before. Okay. And sometimes too, we want to identify isolated members. Okay. Okay. There may be some members within the organization that are isolated. I say, on person network now. For example, let me see if I can find something here for you. I'm not getting any of them, but I think moving forward, I'll get something to show you. I definitely will get something to show you. That's the isolated guys. And sometimes you also need to understand that some of them are bridges. When you take that guy out, will begin to fall. Okay. So going forward, I'll show you some of these things. Okay. Okay. So the central theme of SNA data is relationships. Okay. I think we've said that, and we can obtain some of this data here from service. Okay. If you tend to conduct a service study, you can use that for network analysis. You can also get SNA data from some archives. Okay. More like secondary data source. You can get data from that place. Okay. So the kind of relationship we are interested in mostly sometimes maybe social roles. Oh, myself and this supervisor, a teacher or a friend. It can also be kinship, whether you guys are related. It can also be affective, more like affection. So whether you like someone, you dislike someone, you respect someone. So within the HR space, you may want to come out with affection network for your organization to see that I say just draw the network of the actors, then map it out, just like this one here is mapped out. This one you'll be able to come out with the network structure. Then you will understand what is happening. until you come out with the network structure, it becomes very difficult to understand what's happening in the organization. Okay. All right. It can also be something related to resources, some actions, in fact, anything at all. Anything at all. Okay. So if you want to go to the field to pick data on social network analysis, it could be as simple as a binary. So I come to Josh. Maybe you are Josh. I put your name down, this person. Then I ask, do you smoke? Yes, no. I put it down. Then I go to the next person, maybe Christy. Do you smoke? Yes, no. Then when I'm done, I'm now going to look at the relationship between Josh and then Christy. Then I'll be able to identify that, oh, it seems all of the guys that smoke within the organization are connected one way or the other. Okay? So it can be as simple as a binary. It can also be categorical. Something like I agree, I strongly disagree, all of those things. You may want to come out with a network to map out all of the people that are saying that they agree and all those who are saying they disagree. Look at the similarities and differences between them to come out with a conclusion that, oh, it seems all of the males are saying that they disagree and all of the females are saying that they agree. Then you have two different categories of which you may want to study or dig deeper in. So look at this one here. This is how SNA data can look like, something like this. So you can say that, okay, you identify someone. So these are actors, okay? You identify an actor like Pasty and another actor, I'm sorry, like Esther. Then you want to find out the relationship between these two actors. Then this can be a friendship. So you can put the actor here and an actor here. Draw a line between them to say this is friendship. Then you look at Esther and then Perry, you put friendship over them. You put, then you, it's going to be like, okay, if my friend is Esther and Esther's friend is Perry, then there is a probability that myself and then Perry will have something in common. We may be friends. So you can even calculate the probability that we can be friends in future. And that is going to tell you that, well, if I know this person and this person knows this, more like transitivity rule, then chances are that this person and this person are going to be friends someday. Okay. We can also look at maybe Evans and then Pasty can be like colleagues, this and that, supervisor. We are just interested in the relationship that's going on. Okay. Now, you see this kind of relationship here. This is a different form of relationship from this one. So we have this one and Lord. The type is negative. Okay. I don't really know exactly what they are looking for, but it could be, are they friends? Maybe yes, no. Sorry. It could be, are they friends? Yes, no. Are they this, positive, negative? Okay. So this is how SNA data looks like. But usually, before you run the analysis on SNA data, you have to code it because it doesn't accept this kind of data. You have to say, okay, wherever I see Pasty, I want to put 1, 1, 1. Wherever I see Esther, I want to put 2. So what is the relationship between 1 and 2 friends? What is the relationship between this and that? Okay. All right. So SNA, let's say relational data collection. If you want to collect data for social network analysis, of course, we can use surveys, for which you said you would want to use a bounded approach where you want to get information about all of the, maybe you have knowledge of all of the members or actors within that network. You can also use interviews. Okay, I interview, how many of you are this? They'll raise their hands. How did you meet this person? Blah, blah, blah. So depending on the kind of question you want to answer, you put the appropriate questions here through interviews. All right. Then if you want to construct a network, okay, the method of collecting data, we have several of them, but we have one which is the full network method. But with this one, you have to collect the data from every single actor within that network. This is like very, I don't know how to put it. If you have a fair idea of the network size and everyone in the network, then this is good. So for example, if I come to your class, I know all of the students over there, then I will use a full network method. But the space where I can't find them, then we can use something we call the snowball method, which is a referral approach. And see, I'll start with a key actor, the one that I know. Maybe your class, I don't know everyone, but then I want to be able to identify all of the members in the class. I know Josh. I'll just go to the Josh and say, "Hey Josh, who is in your class?" He will say, "Oh, Nanama." Who is Nanama? Then I'll go to Nanama. Then Nanama will say that, "Oh, we have another guy called maybe Muslim." Okay. And, okay, it's not charging. Then Nanama will say that I know a guy, okay, called oh, Nanama will say that I know someone called this, maybe Suleiman. Okay. Then that Suleiman will also direct me to another person, direct me, like it keeps going. Recently, we did some research with Aunt Matt, Dr. Matilda, if you know her. The research was we identifying traditional health supply chain actors in the country. So we're identifying the Wanzams, the is it Bone something, the herbalists, these people. But you see, it's very difficult to find them. You don't really know all of them. So when we meet this Wanzam, we ask if he knows any other person who is also doing or into this Wanzam. Then he will direct us to the next person. We'll go to that person. He also direct us to another place. So through that referral thing, we're able to identify all of the Wanzams within a given space. You understand that? So to do social network analysis where you don't have a fair idea of all of the actors, you may want to go with a snowball methodology. But using snowball is like, I'm looking for some people, but I don't know them. All I know is one person. So in case, let's say I want to identify all lesbians, or let's say about 50 lesbians in Care University. I don't know them. It's not written on their faces that they are lesbians or this. But if I'm able to identify just one person who is a lesbian, that person will direct me to the next person that, oh, this one is also one of us. That one person will also say that, oh, Mami Okia is also one of us. You will end up identifying all of the lesbians on campus, okay? So that is a snowball methodology here. Okay, so this one, I wouldn't want to talk so much on it, but we said this is the network. We have node, which are the actors, and then the relationship between them, we usually call them edge. Okay, so a network is made up of, a network is made up of nodes and then edges, or actors and relationships. So just know that the node is the actor and the edge is the relationship, which happens to be the line or the link between all of these actors. Okay, this is the guy that I was talking about, the unrelated guy. Do you see? As Watino is not connected to Wemo. When this guy is connected to all three, this is connected to all three. Okay, that becomes an issue. So you may, if you are the HR manager, you may want to give an assignment, put this person and this person in the same group, because this guy knows this one already. So if you want to create additional relationships so that they can all communicate to do something, then you may want to pair this person here with this person. Then they build a relationship. The next time you pair this one with this, at the end of the day, you see that everyone will be connected to the rest of the members. Okay. Now, this relationship can be either directed or undirected. So when we talk about directed and undirected, we are interested in, okay, myself and Josh, I know him. Okay, I know him. But does he know me? Okay. So it could be that I know him, but he doesn't know me. Okay. It could be that I know him, but he doesn't know me. Okay. So if we are looking at I know him, he knows me, like the direction, that is what we call the directed network. So look at this one. I know Mahama, but Mahama doesn't know me. He doesn't even know that I exist. Okay. So that is directed. But the undirected one is we are not interested in who knows who. All we know is that there is a relationship between them. the relationship can be maybe talking mate. Is it this guy who wants to talk to this one, or this guy wants to talk to this guy? We don't care. But if you're interested in, does this guy call this? Does this one also call this? They'll go like, no. Every single time we are winning a freeway. So it's like this guy, not a friend anyway, but we need him no, and a friend. But undirected one, we are not interested in that. We are interested in there is a link between both of you. That's it. Okay. So this is an example of a directed network. Okay. So you find this thing here in my info work. There's the health supply chain network for Ghana. So if you want to identify all of the actors within the chain, we've lumped all of them here together. So you see that in the Ghanaian healthcare supply chain, we have manufacturers. You see the relationship between them. This guy here sends some materials to distributors. We have no. So you see, when I'm talking, I hardly come to the comment section to look at what you are writing. So if you have any question, just you can raise your hand. I'll call you, then you speak. Okay. Otherwise, I'll finish class and I'm going to say, "Ebia message biaba." You get it? So he's trying to understand, say, when you are collecting your data and someone is not willing to share additional information to you, is it like that's the end of it? Well, that can be a disadvantage. Okay, it can be a disadvantage. But if that person cannot direct you to the next person, yeah, you can assume that you are done collecting the data. Okay, that is given your sample size. If you are collecting data from 500 actors, or you don't have any idea how many actors are in the space, but you want to identify them. Once this person, if he goes like minimobia, that's okay. But he knows someone, but he doesn't want to tell you, then there is something you have to do. What I say, hey, oh baby, if you know, there's something you have to do, and they will direct you to that person. And oh, Michael is not hearing us very well. Okay. So Michael, you may want to check your internet. Okay. So if you look at this one here, we have everyone in this box, the producers and distributors. This is the relationship between them. Now, when we try to get products from these people by the private health service delivery people, okay, it comes straight down here. And those in the public sector, you'll have to go through the central medical store, and the central medical store will bring it to the regional medical stores, and the regional medical stores will now give it to the health facilities over here. And we are saying that we have other actors. These guys, they are not part of the traditional health supply chain, but whatever thing they are doing is actually affecting the flow of information and cash and everything within this particular chain. And then we also identify there is something called purchasing organization, but we couldn't find this one here in Ghana here. We found this in the literature. That says that we have this category of people, but we simply couldn't find them in Ghana. And someone is saying something. Okay. Yeah, you may want to say something.
Yeah, Pasty. I'm a little bit confused on the initial charts based on
The
the
initial,
explanation. The previous, just the previous chart here.
this one,
Yeah, this
or this one?
both. So
This one.
this one, the other one that.
Okay.
Yeah, this one. So
Okay.
initially, this is how I understood the explanation you were giving on the directed path. So whenever the arrow points to somebody, the one in which the arrow is pointing to doesn't normally know the person, the entity in which the arrow is coming from. Is that it?
No, that's not it. But over here, we are looking at flow of information.
Oh, okay.
The directed one. It can be information, it can be everything. So this can be father, this can be son, and this can be just anything. So the father gives money to the son every single time, but then the son doesn't bring any money to the father. So this is a directed relationship or network.
Okay.
But
So
if you want to look at, this is father, this is son, So there's some kind of relationship between them, but we are not interested in the direction. Then we can look at something like this. This and this, father and son relationship.
Okay,
Do you
so going
understand?
to, yes, now going to your next chart. So in
Okay.
this case, the relationship you are looking at between the manufacturer and the distributor is how the manufacturer submits whatever to the distributor, not the communication between the two.
No. So this one is not looking at communication. This is a flow of products
Okay.
and then services.
Okay.
So the distributor doesn't provide any kind of like mainly service to the manufacturer. All they need is to go and buy their product, and the product is moving from the manufacturer to the distributor. And the product is, of course, there is some kind of flow of cash, okay, or funds. Because if the products are coming, this one will have to go. But in this particular research that I was doing, I wasn't interested in flow of funds. I was interested in product and services. That's all.
Okay. So it's all dependent on the context of whatever you are doing.
Exactly. Exactly.
Awesome.
So what you are looking at.
Thanks.
And it doesn't necessarily need to be directed, depending on what you are talking about. For example, if you want to look at between yourself and your wife, what is the relationship between you? You don't have to direct it. Okay. You shouldn't have any direction that we are couples, like we are married. That's all. The relationship between us is just that we are married. But if you want to look at who is responsible for maybe ABC, I don't want to assign responsibilities with respect to gender, but let me just bring it to our context so that we can understand it very well from the African perspective. Who does all of the cooking? Okay, then you will see that the woman does the cooking and then gives it to the man to eat. So over here, there's going to be a directed kind of network we are drawing. Do you see that?
Yeah.
So it
Sense.
depends on what you are looking at.
Thanks.
All right, sure. So in social network analysis, in addition to identifying the flow of information and identifying the actors and the relationship between them and that, we have some metrics, okay, for measuring whatever thing is happening. We have a node level metric and then we have the network level metric. So the node level metric is like, we are looking at like individual. So for example, who is the most powerful in this network? That becomes an individual level kind of metric or analysis. Do you understand that? Who is, let's say, the bridge between 1, 2, 3? That becomes a node level analysis. So whenever we are doing an analysis, but then our question is about who. We want to identify a specific actor, then it becomes a node level because we are saying that the actor is also the node. But if our question is about the entire network, like this one, this network here is cohesive. If we are asking the question of, is the healthcare supply chain cohesive or maybe it's not, then we are saying that we are doing a network level analysis. We are not interested in the individual ones, but then the entire network. So we have degree centrality. We are going to explain what that is. We have the closeness centrality. We have the betweenness centrality, and then the eigenvector centrality. We have a lot of them, but we won't be able to go through all of them. So you may want to quickly search to see what others are available. So yeah. You remember the degree thing that we're talking about, the degree, the closeness, betweenness, and all of these things. We can explain that with just this simple network. Now, this network is saying that this is the degree, which is the number of connections. So the one with the highest level of degree has got, that's the highest degree. Okay? A person who is well connected. Do you see that? Who is well connected? So over here, we are saying that this guy here is well connected. Well, probably if you look at it, the connections, also chain will be added. This guy's connection may be more than the connection of this one because this guy is connected to this, that. At the same time, he's connected to this. If you look at this one, this guy is connected to just 4 of them. This one is also connected to just a few of them. So this guy here becomes that degree, okay? This guy, degree centrality. So you can just look at the network to tell who is this, who is that. Now, if you look at the closeness, This guy here is the closest to get information across both here and then here. It's this guy. It is able to access all of the nodes quicker than any other person. So if you have an organization, you draw your network out, you run your analysis to look at the closeness centrality. Then you can tell that this guy here is the quickest among them. This guy here can push the information faster than any other node because he's connected to a lot of people. He's very close to a lot of people than any other person. Okay. And this is the betweeners. The betweeners is like in the organization, I say, groups me. In fact, a group is called a clique. So this one here, and the clique is like all of the members are connected to each other. Ubia are connected to each other. This we can't call this one here a clique because this guy is not connected to this guy. Do you see that? I say everyone is connected to each other, but this guy is not connected to this one. Okay, so this guy here fails to be a clique, unless of course we want to remove someone from it for all of them to get connected. But look at this one here. Here, forget about this guy. He's not part. This guy is connected to all four. This is also connected to all four. This is connected to all four. Connected to all four. So this group here is a clique. Now, if you look at this group, let's assume that these are two enemies, okay? Enemy group 1, enemy group 2. Now, you see that there is one guy in the middle who talks with someone in this group and at the same time talks with someone in this group. And that guy is the betweenness, okay? He is the one serving as a bridge between these two different groups. In every organization, there is that guy over there. Obaha, he will say something sweet for people to know that, oh, okay, Obaha, he knows what to say here for them to know that Okamo. So he comes here say something different. He can also come here say something different. He's in the middle. Okay, that guy is the betweeners. So assuming there is a problem between this tribe and then you want to resolve it, when you come here, just target this guy, remove him. Once you remove him, there is no. These people cannot know the secrets of this one. This can also know the secret of that. But if this guy is there, or two-way secrets are not their baha, or two-way so they are not their baha. So that becomes a challenge. I don't know if you understand what's happening here. Hello?
Yes, Pastor.
Yes, Pastor.
Okay, all right. Once you understand this one, I think we are good to go. So at the node level, metrics, like I'm explaining the degree centrality, like from here, we are saying that it measures the number of direct connections a node has in the network, okay? So, this guy here is the actor, okay? Now you can see some tiny things in here because when I was doing this particular research, I was coming from a systems perspective. That this actor itself is a system. As a human, so so if you're a human being, you have you are a complete system, and you have a nervous system, you have a digestive system. So a lot of things are going in. Okay, that's what we have here. So if you want to look at the number of direct connections, so which one of them has got a lot of direct connections? Then of course this guy, because he's directly connected to this, directly connected to almost everyone here. Okay. So nodes with higher degree centrality are more connected and may have greater influence or access to information within the network. Because he's connected to a lot of people than any other one. As information in our name, and he's got greater influence. So in organization, if you do your network analysis and you come to realize that, oh, this guy, the degree centrality is this particular actor, then whatever thing you need to do, you have to do it. We won't say because he knows a lot and then he has got influence, he becomes powerful. And to man pusa or kasa, the rest of the members won't be tea. But if this guy, you tend to give this guy here some power, or kasa, that's a way kasa. All of these people may listen to him. They won't listen to this one. So it's some kind of game, that you have to really pay attention to. And this is also closeness centrality, which identify how close a node is to all other nodes. So it's like, how close is this guy here to this one? Forget about the positioning, but if D wants to communicate with F, D will have to send a message to C. C will have to share the information with A, then A gets it across to F. So we are looking at which guy can easily access like all of these people. Which one is closer to like majority of them? And we see that this guy here is closer to most of them than any other person. Because you see, this guy will just move one step to get access to almost everyone, with the exception of D. One step, he will reach this one step. But if this guy wants to get access to this, we'll be moving how many steps? 1, 2, 3. Okay, that's the that's what's happening here. So nodes with higher closeness centrality can reach other nodes more quickly and efficiently, potentially acting as information brokers or facilitating communication. So say OpenCell sending information across to this patch-up. Now the guy know what the closeness centrality know. He will disseminate it really quick than any other person in the organization. Then we have the betweeners. What I say? This betweeners guy. I think this guy here explains it even better. Okay, we have this group and then this group. So whatever information that's coming, he knows it. Okay. Okay. Then we also have the eigenvector centrality. Okay, which evaluate the importance of a node based on the influence of its neighbors. And let's look at something like this. If I pick this node, can you tell me whether or not this node here is very important? Or the kind of power he's got because of the kind of people he knows. Okay, that's what the eigenvector centrality is talking about. So we want to see that, okay, of course, this guy here is not connected to a lot of them. But is this guy connected to the most influential person in the network? If yes, then he's important. What is it? I don't know if you understand what I'm saying. Hello, are you there?
Yes, Pastor.
Because maybe I will share me. I know just one person, and that one person I know is Mahama. And Mahama knows almost everyone. So I become powerful. We hear Bibi na se me catch Mahama say Mahama mpacho we and farmer on farmer. Okay. That is what the eigenvector centrality is talking about. So if you look at the most powerful guy in the network, look at the guys that powerful person is connected to. Those people are also very powerful. They serve as advisors. So if you meet some lady and you are interested, now we'll catch her no. No, because I'm going to think about it. We say, or they call board of directors. They could do board of directors. No, they are going to decide. Sometimes they will say yes. We could do board anymore. The board will say no, we don't agree. We won't say no asamba. So you come to realize that people. Okay. You come to realize that some people are not really connected, but they are connected to people who are really connected. So they become powerful. That is what the eigenvector centrality is all about. Okay. Now, when we come to the network, before we move to this one, any question about what we've discussed so far? All of these guys, the node level. You see, the node level, we're just interested in the individual actors. The board is chaired by Melody. Ayeka. Okay. We have the network level. Okay. So the network level is not looking at the individual actors. No. It's looking at the entire network. We want to examine it as a whole. So when we talk about the density, I say which is dense. What I say, just that. So look at this one here. This is the connection. This guy is not connected to this, nothing of that sort. So the density over here is quite low. But if you look at this one, it's almost everyone is connected to each other. That makes this particular network here highly dense. So a higher network density indicates interdependency and closeness. And so we are depending on each other. So if you have your network, if you look at your organization, that's our network, no, and yet dense, say, it's like, akwa we office or non bit me into there be on that is what's happening over there. But if it's highly dense, akwa we be a person we who not in opinion bar and those kind of things. So if your network is not dense and then you want to make it dense, then you have to configure it. Start putting them in groups. Put this guy and this guy in the same group. More assignment, no more. Then that means automatically you've created a link between this and this. So you can just look at the network structure, look at what is good for your organization, and then configure it that way. So if the network is denser, then it means there is some kind of interdependency and then closeness. Okay, but if it is not, then as a hano, obiaye no hosa so wabin. Okay, as a non and those kind of things. Okay, so network density is very important. So when you calculate your network density, so with all of these things that I'm telling you, when you're done, you can pick my research work, go to the resource section, and then you find some of the density over there. Then you know whether or not the Ghanaian healthcare supply chain is dense or it's not. If it is dense, that means there is higher dependency among all of the actors within the supply chain, the health supply chain network. If it is not, I say, we'll be at independent, we'll be nadia. So you can check those ones. All right. Then we have the network diameter. Okay, the diameter of a network is the longest, shortest part between any two nodes. Okay, so we are looking at the maximum distance or the number of steps required to reach one node from another. And Timothy said, let me go back. This one can explain it very well. So this one, the network diameter is going to give you an average. Say, on the average, if this guy wants to talk to this guy, how many steps should this guy take before he reaches this one? How many steps will it take this guy to get to this one? So this guy will take approximately 1, 2 to reach here. So you look at the value for the network diameter over here. What do you think this is going to be? This is going to be like 2. Do you see on the average? The network density for this small one, A2, is it F or so? No, what's A2? Can you see that? Like 2 point something B. I don't know if you can see, but that metric is measuring on the average. If this guy here wants to talk to someone here, how many steps approximately should he take in order to reach this one? That is what the metric is talking about. And we know that from this guy to this guy is just 1 step. But from this guy to this guy is 2 steps, 1, 2. From this guy to this guy, 2 steps. From this guy to this guy, 2 steps. So as a 2 node also. So on the average, the network diameter is going to be 2. Do you understand that? Oh, you guys, are you there?
Yes.
So if you have a network and then your diameter is very big or small, then you have to understand what is going on in there, okay? So we are interested in the average. The reason why we are interested in the average is we don't want to look at it at the actor level. We want to look at it from the entire network level. And see network way, some information we are, how long will it take me to get it? So, oh, don't worry. Ask just one person and that person will get you the information. But if the network diameter is very big, then it means that if you want to get information across to this one, you have to move like about 7 steps in order to get this particular person. A moment. Okay, sorry, a call came through. So that is what the network diameter is all about. And then we have the network leaks. I think I've explained this one here. And I'll ask one simple question over here to see or to get your understanding if maybe we are all on the same page. You remember what we said about clicks? So we said that with the clicks, all of the actors, when we have actors that are all connected to each other, they will call that one a group. This guy is connected to all of this red. This one is also, they are all connected. Do you understand? The red people. So this is one click. So in your organization, if you come to realize that, oh, nipa 5, they are all connected, but one is not connected to this one. But this group, no, they are all connected. Then we are talking about clicks. Okay. All right. So my question is, who is this guy? Or who is this guy? Or who is this guy? And what do you think is happening here? Anybody, can we discuss this one? Because I think this will be interesting. Let's assume that you went to your company to draw your network and this is what you found out. You realize that there are 3 groups. In that small company, bank, there is one group, another group, another group. Then you come to realize that this group doesn't have access to this. This group doesn't have access to this, neither this and that. But this group knows information from here and here through these 2 guys. This one also gets to know what is happening here and here through these 2 guys. Okay. Now my question is, what is happening here? What can you say about this one? Who are these people? Like, what's going on here?
Pastor,
Yes.
I think they are between us.
They are there between us.
Yes.
Okay. Because they are serving as a bridge, right?
Yes.
Okay. Okay. Yeah, I think it's that, but not entirely, because but of course they are between us, because this guy here is trying to put this group and this group together indirectly, isn't it? Because this guy here comes to, let's assume that is the leader within maybe whatever thing is happening in him. This guy here picks information from this guy and then brings it here. This one also picks information and then brings it here, and then something like that. So if you have your company as an HR person, you draw your network analysis and you come to realize that this is what's happening, then the appropriate steps will have to be taken. You don't just take the steps like that. It could be that these guys are together, they learn together. These guys also learn together. You don't really know what's happening. So once you identify this, you may want to conduct a study, including only these groups, like these actors. You interview them to look at what's common about them. You do the same thing over here. Then you decide whether or not these groups are good or bad. Okay. If there are maybe some kind of bad ones, you may want to find a way to construct a connection between maybe this actor and this actor and this. I said, what's a baby? What's a common album? Do you understand? All right. So the average, yes, come in.
Please, can you call them the click of between us, since the 1, 6, and 11 are interacting together?
Well, I don't know. I don't know if there is something like that, but it looks like they are behaving that way. But I don't know. I haven't heard that kind of term before, though. It may exist, but I simply don't know.
Okay.
Okay.
Thank you.
So the diameter over here that we're looking at, where this one is looking at it from the node level, we have the average length path. Okay. So that's similar to it. So it provides an overall measure of the network's efficiency in transmitting information or influence between the nodes, which is also similar to what's happening over here. So if the diameter is very small, like 1 step, if you need information, just 1 step, you get it. Then we are saying that this guy here is going to be better, because there's going to be efficiency in transmitting information, and yet very long. So this is network cluster coefficient. Okay, the coefficient is going to tell us more about our clicks over here. Okay, all right. So of course, when you draw it, you can get something like this, okay? But we can look at it from the coefficient perspective to look at least how many people did we find in different groups. Into cluster analysis. Cluster analysis, something like I don't know how to put it, but in machine learning, we can do cluster analysis where we can put all of these things into groups. In Power BI too, you can do cluster analysis with the visualizations. It's also there, but I don't know if you've seen it already. All right. So examining actor influence in social network analysis. So the influence of each actor can be assessed using a scale. Okay. I don't know. I think there is some mistake in this profile. So this is how we can do it. Of course, we've been talking about the network. We're looking at the metrics, both at the actor level and the network level. But we're looking at how to collect even the data. What is the format? So we can ask a simple question at the actor level to say that how influential is actor A in relation to demonstration? So we can who say, oh, we about demonstration there are influential. So we are looking at some kind of rebel leaders. Do you understand? Within the organization. So what pick here now what rate it? Oh, with the sorry. With the or very low influence as a on but the 4 to 5 people highly influential. Do you understand that? So you can see that is what we have over here. If you look at this network here, the 4 to 5, this guy here is highly influential when it comes to demonstration. We also here influential when it comes to demonstration. We also influential, but C5 on the end you we anyway. Okay. These are the influential people. So assuming you construct the network for your organization and you see something like this, they say anyway. These are the rebel leaders. Then it is about time. Maybe you have to do something about it. I don't know what you would want to do to put them in training. Maybe create a different kind of connection for them, sack them, take them to a different department or a different region. Just anything you may want to do to resolve the issue. So it depends on what you want to do. Okay. So over here we are looking at the actor. We want to examine the actor influence on the network. And over here, we want to examine the network structure. Yes, yeah. You can come in.
Pastor, so if you go back, okay.
Here.
So I was at the question you stated, how influential is A in relation to the demonstration? And I'm looking at the network, I'm not seeing the symbol like A anywhere. I'm just seeing the ratings. So I was confused as to how are we going to be able to determine that this actor is A, this actor is B, or this actor is, or isn't that the question you're asking?
Oh, so the A over here is the actor. So how influential is this guy? Relation to, so the A is just a variable representing the name of that particular actor. So A here is for actor. How influential is this actor in relation to demonstration? So it's like we are asking how influential is this guy in relation to demonstration. And will be a rating is a 1. Just on there, why him? But anyway. They are the confusion guys.
Okay.
Then over here, we are looking at the network structure. Okay. So to understand the social network, it is not only important to analyze just the relationship between the actors, but also to consider their location within the network. In fact, Baby Omowono is very important. Okay. Now, if you look at this, even from here, look at those with the low influence. What do you see? Look at where they are. They are not even connected to themselves. Do you see? They are not. And they are maybe the latter part of the network. Okay. But if you look at the highly influential ones with respect to demonstration, see, this guy is connected to someone who is connected to a very big network like this. This guy is also connected to this one, who is connected to a big network like this. So you can see that usually guys now are more low influence. No, you see their relationship. As some of you say Ned be pekasa anyway. Now they are they become
But then,
very.
let's see, why would
Yes.
they label the one in the corner as 4 when it's not connected?
Which
Or
one?
the one at the top right?
Top right. This one.
The
This
4.
one.
Yes.
This one.
Yes.
You are saying why would they label it as what? 4?
Yes.
When
It's not having any connection thing.
No, this guy is having a connection. It's because look at this one. This guy here having access to this one, like he's got access to all of this because these are common.
Okay.
Okay. And this is not like maybe someone went to do a study and then came out with this. This is a hypothetical example to explain to you what is actually happening here. So this wasn't part of my research.
Okay.
Because maybe what I am the drawing. Okay. All right. So over here too, we are looking at the network structure and we are saying that the positions of some of these actors is also very important. Now, these questions are going to help you to analyze this particular network. Sometimes, depending on the kind of question they are asking, you have to know the kind of metric to use. For example, if there is a question of, are there any actors with a high number of connections? What is the implication? What they are asking for is the degree centrality. Is that not it?
Yes.
So. That's what the question is about. Maybe they may not ask you because if a company comes to you, ask you to do a research for them that which of our employees is highly connected. In fact, that company awarding you that contract doesn't know that there is something called degree centrality. It is up to you to understand that if we are talking about high number of connections, then we are talking about degree centrality. All you need to do is to calculate that. Tell them that, okay, Nanaya is the person with the highest connection in the class or something. Okay. So something like, are there any actors that appear peripheral to the network? Shakwawi. Mfan say BBC. Mfan say BBC. Okay. I say I don't know how to put it. More like disjointed. You know how I mean in Kano. So much it okay, they are not really connected to people gidi like that. Do you see? Because if you look at this guy, he's connected to just one person. He's not connected to Nipa two, just one person. Okay. So we have how centralized or interconnected is the network that we are looking at. Do we have any clicks within our network? So depending on the kind of question being asked, then you have to understand which kind of metric you would want to use. Okay. Now, we have something like this. You see, right now we understand some of the key terms. We've seen some few examples of this. Why are we even interested in identifying who is the who has got the highest connection, what are the clicks, who is not connected to anyone? It's because we want to assess the network risk. We want to see if there are some kind of issues within our network. And if we identify any issue in it, how do we manage it? Okay. So when it comes to the network analysis, whatever thing we find, we have to assess the risk. And in your company, you were able to get all of maybe the employees, you ask them some few questions, you're able to construct a network. If you look at the structure of the network, do you think it poses some kind of risk to the existence of the company or the company's profitability? Do you understand that? That is the risk that we are going to assess. So the first one is dependency. You will need to pay attention to high dependency on a single actor. Okay? I say, nipa baako, wenya issue and one neighbor, wenya issue and one neighbor, wenya issue and neighbor no. That is the bottleneck. The reason is, that's how nipa ne yare na obeja ejuma no. Your business is going down because I said he knows almost everything and the rest don't know. So once you identify that no, there is a high dependency on this particular actor, it is about time. So you pair that actor with someone else. Like they should start learning from him. Do you understand that? So when you find high dependency on a particular person, then you know that there is some kind of issue with your network that you have to really pay attention to. Okay? And see, enka oba hana mfa nse epe bibi let's say this one, A, where I say, Ubia here, BB, they will have to go through him. If I have to move from here to here, you have to even go through A. Then it makes A, I say, Ubia depending on A. So what is making A special? Ubia depending on this person. You study this one, you pair this one with someone, make sure that whatever thing this person is having, so that instead of everyone going through this one, they can also go through this to have access to the rest of the actors in the network. In that case, we're reducing risk, because if this guy is not there, they can now fall on this person too. So that is some kind of risk in the network that we may want to pay attention to. Then we also have conflicting relationship. We want to look out for broken relationship which impede the entire network. Okay? New actors or interventions can be introduced. Okay. New actors or interventions can introduce conflict for resources or control. Okay. So we want to know if there are some kind of broken relationship. First, this guy was connected to this guy. But because of ABC reason, there is no more connection between this guy and this one. And that is what this guy is saying that we should pay attention to. Okay. Then finally, we need to pay attention to exclude, more like excluded actors within the network. Maybe because of gender or just any reason. So we say in your network, but could be as a watching as will be unfun because of maybe how he is, maybe an agenda and because of cancer, yeah, LGBTQ, will say, hey, we the papa, we the we a bear now, banner, or so because of that, now as a watching home from the network, okay, that becomes a challenge, okay. So we need to understand the reason behind the structure of the network, and then uncover the reasons for the exclusion and how best to overcome that. So as you are building your network, you need to pay attention to all of these things because they can pose some kind of risk to your organization. Okay, disincentives for change. This is very important. We need to pay attention to how interventions will change resource flow. Obi or how in organization, I said like the rebel leader thing that we were talking about. When you say this and that rebel leader say no, if they oppose it, asamaba. Okay. So once we identify something like that, it brings some kind of risk. It introduces risk to our network. So we need to pay attention to. They said these rebel leaders are management releasing notes. The rest of the employees will follow said that. Do you understand that? Or muntin a demonstration. When I say Ghana entire demonstration, we have a lot of people who are afraid. Okay. We have a lot of people who are afraid. But if you get one strong guy who is not afraid, that's a person who lead the youth to go and then fight her, you see that they will all follow him because Okasa Obiabiti. Okasa Obiabiti. Okay. So if you are there and then you identify this kind of person, why you be found? And I'm sure that our politicians know some of these things. So if you rise up and maybe you are good in this, you are amassing followers who are listening to you and this, something like that. Okay. So we have the like me relationship. So you notice that people are going to surround themselves with those who are like them in terms of gender. Break time, a man in a group one place, not a man in a group one place. While one gender, I don't want to mention him, while one gender aiding conconsano, the other gender will be discussing soccer, any like making disciples and things. Do you understand? So because of that, you will have the like me relationship. So the like me relationship also introduce some kind of risk to the organization. But we also have some structural challenge. It depends on the structure of your network. The structure of the network can actually introduce some kind of challenge. So if you have a betweeners, okay, you have this click, and then there is a betweeners. That guy now has 7 years bridge. If he is no more, this group are telling where free way it will be very difficult for this group to connect with this group because the bridge is broken. Okay, so these are some kind of risk you may want to pay attention to. We have a lot of them. Okay, but to manage some of this risk, we can decide to build additional networks. Do you remember that I said I think we have something like that. Wahanti, we can decide to build another network within the network. Okay, if you identify that, okay, this is your network. Kwame is not connected to Ama. Kwame is not connected to Yao. You can just put 1, 2, 3 in the same group, give them tasks. By the time they are done, they are connected. We'll create a new kind of link between the actors that didn't know each other. Okay. Then we also have, I think we've spoken about the incentives for change. I think it's a repetition. I have to take it out. And then we also have a critical relationship building. Okay. Then we also need to tap into underutilized support. In fact, these are things that maybe time you can just go through them. It's nothing really complex over here going on. All right. Now, this is just a scenario. Okay. Now, if a funding source ends or key actor leaves, what will happen to the network? This is a simple question we are trying to ask. All right. Let's say you are in an organization and we have a company that is funding you, okay, or maybe some kind of NGO that is funding you. They bring you money to do something. We also have some key actors within your network. I say, when you're more the question is, if these two people or one of them leaves, what is going to happen to the organization? And once we know what is going to happen to the organization, what is it that we need to do about it? Now, look at this. This guy here is a donor. Okay, I don't know what this is an image I think I got online to explain whatever thing is happening here, but I don't know what this IRC is all about. This is about NGO. These yellow guys, they are NGOs like these guys. Oh no, that's the IRC. The NGOs are these ones. Then we have the healthcare providers, which happens to be these ones. And then we have the community authorities over here. Now look at the first one. This is the original network, okay, where we have the donors, they give us money and everything. And then we have critical actors that are very critical. They are putting things together. They are also here. So this is the structure of your network. Now, B is saying that if key actors leave or the funding agencies leave, what is going to happen to your network? Now, look at this section of the network. I didn't say it's because this guy left. Just this guy here. This guy left. So there is no connection between all of these guys. So because one person left, look, here. I say Wejumano. There is no connection between all of these guys. Do you understand that? There is no connection between these guys. Now, how do we work around this one? The way we have to work around it is to not to allow this person connect all of these people alone. Then he connects to this one. I say, Bibiano, we should go through him. Only why this guy doesn't know that I have not done your money back. So the arrangement is that, okay, why don't we create a relationship between this guy and this one? And the relationship between this guy and this one, such that if this guy leaves, then this guy can still find a way to get whatever information or resource across to them. So that is what we have here. We can see that this guy here is now connected to this, and we've also created a connection between this guy and this one, which is also over here. Do you understand that? Okay. Now, look at what's happening here. You see these two giants. You see, this guy is connected to this click, and this guy is also connected to the other part of the network at this point. This guy and this guy are connected, okay? And this guy is connected to just this one. He's not connected to this. Let's assume that the connection between this and this is also broken. Then this guy here is going to struggle. Now look at what's happening here. We have this click. They don't even know how to connect to the rest of the world. We have this one too. They also don't know how to connect to the rest of the world. So it is about reconfiguration of this network structure. So we're trying to answer this question. It's about, we need to simulate to remove some few key actors or donors from it. to look at how dismantled our network will look like, then we need to also create new relationships. Okay. By creating new relationships, this is how the thing is going to be. Such that in the worst case, if these guys are not there, we can still have these connections keeping the network running. Any questions up to this point? Do we have any questions? And I made often so. Any questions? You are thinking about your questions, eh?
Yes.
Okay. All right. Okay. So now that we know about our network structure, we know some few metrics, why it's even important to look at them. We said as we are building our network, we'll be looking out for some few risks and how to manage some of these risks. And the question is, once we know some of these risks and we try to reconfigure our network so that it doesn't break down, what is next? There's something we call action planning. Of course, when it comes to action planning, like you identify the issues, what are the next steps? Now we have a lot of frameworks for action planning. Okay. In this case, we are using the SWOT analysis. And the SWOT analysis is something that almost every single one here have known this for a while. So we need to pick our network, then ask ourselves some few questions. What is the strength of our network right now? So if I have this network structure, this one, A, the question will be, what is the strength of our network? What are the weaknesses? What are the opportunities and what are the threats in this network? We identifying the strength, weakness, opportunities, and threats is going to help us to simulate this and then reconfigure our network. So this is a call for action to help us understand what we need to do within our network. All right. Okay. So for strength, we are saying that we want to look at the number of influential actors who are positive about a given issue. Okay. And if you want to introduce some new policy and you have influential actors who do not buy into that idea, that becomes a challenge. But if you have all of them buying into your plan or idea, it becomes a strength for you because once they agree, the other members of the organization are going to agree. Then you also look at weaknesses, a number of negative actors who block the action of those who support the issue. If you tend to have actors who opposes new policies or an issue of that sort, then that becomes some kind of weakness in your network. So it is about time you paid attention to reconfiguring that network. You also want to look at opportunities and some kind of threats where you want to look at some advantages in the network that you haven't tapped into. Okay. So once you realize that there are some kind of opportunities in your network that you haven't tapped into, then that forms the opportunity in the SWOT. And we also have threats. What is it that you think can affect your network? Okay. When we have highly dependent actor within your network, then you know that that person can be a threat. And just say, this actor in the organization, you can't do anything without him. That person becomes a threat because it's now that's all. The entire business is coming down. Okay, the network is going to break down. So are you trying to there are other frameworks over there you may want to look at, but SWOT analysis is going to help you identify the strength, weakness, opportunities, and the strength in your network. Okay, so this is just an example of SWOT analysis, and you use that for strategic recommendations. So assuming this is a research work that you've done, you've examined the network structure of some company, giving them some kind of advice, ABC thing. Now, you need to now tell the organization what they should do, because the company paid you to do their research. You are the researcher, you identify some issue, you need to tell them what do you think is the right thing they have to do. So you can use the SWOT analysis to provide recommendations. Yeah, sorry. So if you are looking at the threats over here, then you may want to ask them to create network within the current network, and any other recommendation you think is going to be helpful. Any questions? Because that's the end of this material. Any questions? Any questions? Any questions?
Yes, Pastor.
Yeah.
Please, when it comes to the closeness and the what's it called? You didn't see the slide. Please, can you move up to the diagram, please? Can one entity have more than one characteristic for that?
Which diagram? Let me see.
The closeness diagram.
This one.
Yes, this one.
Uh-huh.
Are there situations where one entity can have more than one property?
Yes,
character?
exactly. Exactly. In the study, the research that I did, I realized that the IT service providers, they were almost everywhere. They were serving as the closeness degree, the betweeners. In fact, the IT people were doing all of these things. So it comes to tell us that within the healthcare supply chain, the modern healthcare supply chain, IT people, they are not part of the supply chain network, but their influence is very great. Because if you have to request for products from maybe US, so one for playing in free hand code, you use some kind of software to make the request. Assuming you are out of stock, you need to make a request, and you say network now say, so you can't make that request. That becomes a very serious blow. Okay. And if you want to communicate any information to someone else, you have to go through the IT service providers, because so one actor can serve, in fact, can be a lot in a single network. And once you realize that one actor is becoming too powerful within your network, then there is something you have to do about it. Otherwise, if free horse is here, everybody is going to struggle.
Please, another question. With the snowball method, like you stated earlier, does the referral have to come from the person you are interviewing, or it can come from third party or a different party?
It can come from anyone. It's referral. So,
Okay.
but usually, the reason why we recommend that the person you are interviewing refer you is, see, best of a feather. I said, he knows the rest of the people. If you come to ask me about a pilot, I don't know any pilot here. Minimum, but if you are interested in, let's say, accounting lecturers, then I can give you a name like, okay, Prof. Q. Now, when you go to Prof. Q, probably he's the only person I know that he's a lecturer in the accounting department. When you go to Prof. Q, because he's a professor over there, he knows the rest. He will point them out to you that this. But sometimes you may have someone who is not part of the group that you are going to interview. However, they have a lot of information. They can identify a lot of people for you. Okay. That one is there, but the underlying thing is that it is a chain referral. You meet this person refer you that, oh, go here, ubenyabi. This one will ask you, go here, ubenyabi. That is the whole idea about the snowballing technique.
Okay, thank you.
Yeah, you're welcome.
Pastor,
Yes, coming.
please. So how will you classify people? Just as we're giving this example, they are not part of the group, but they know everything about the group. But when they give you the information, they'll tell you, don't mention my name. Or how will you classify such people?
Yes, okay. So it's not really about the classification, but when you are conducting a research, okay, there is something we call inclusion criteria. So for example, that is what they call your sample. Okay. There should be a criteria for selecting someone. And you can't say that you are doing a research to investigate how lecturers are coping with female students, like how male lecturers are coping with female students. Then you go and ask the registrar. You see, you can't interview the registrar in this case because he's not a lecturer. Because according to you, the people you are going to interview are supposed to be lecturers. So sometimes you need some kind of information. But what you say, Mamiesi to he's not part of the group, but you know that Mamiesi can direct you to where you should go. It doesn't mean that when you go, you have to interview Mamiesi that, oh, I have these questions for you. What is your opinion about this? What? No. The reason why you went to Mamiesi is, do you know any mechanic around this place? The Mamiesi will say, oh, yes, we'll call this place Albania Bako. Now, Mamiesi is referring you, which forms part of your data. But in your analysis, you don't have to include Mamiesi because it doesn't form part of your inclusion criteria. Do you understand that?
Okay.
Do your analysis now. On need your cry and recording po. Because let's say we'll be about which car engine is the best. Maybe is it Toyota? Is it Chevrolet? Is it maybe Benz? Is it Audi? Is it BMW? But you can't find these mechanics to ask them. The best person you may want to ask is Mamiesi or any driver. But according to your research, you are saying that the people you can include in this study are all mechanics. Into which your driver near? Or my response and you they just listen, but you can't add it to your result or the data you want to analyze. So that driver may say that, oh, I'm in phone call, baby, I'm fixing a car. When you go and meet a mechanic there, that mechanic also knows another mechanic elsewhere. So then the number of them say, oh, mechanic back on so hand to be a friend. They know themselves. If someone doesn't form part of your inclusion criteria, you drop all of them. But of course, they can direct you in your data collection though. Okay. So any other concern?
Passive.
Yes.
So the softwares that you mentioned that they can be used to display the network. You mentioned that you're familiar with the, I think, this is Jeffy or?
Yeah, this is it. I'm trying to, can you see it?
No, we can only see the PPT.
Oh, okay, I'm coming. Let me stop sharing. Let me do this. Oh, no, not this one. Can you see Gefi?
Okay, yes.
This is him. This is Neweno. So this is Gefi. This is where we put. So you can see average degree, network diameter, intensity, all of the things we are mentioning. You find all of them here. So when you get your data in, you just try to run it and it gives you the result. It will put the network structure over here, like everything. If you want to redesign the network structure, you can use some of these things. And this is where your data is going to be, the data that you load in. Yeah. So it's nothing. Yeah, come again.
Do you have a typical example that you can show us?
A typical example
of your data.
Some kind of, maybe some kind of data that I've worked with.
Yeah, something like that.
I don't know. I don't know if I've removed this, but that is actually what I use for my research work. I don't know. I'll need to search for that data. Let me see if it can take me there straight. No. Okay, a moment. Let me check. This, my research, and my info work, and social network analysis here. Okay, yeah, I think I have it here. So this is my actors, the actual, then I have all of my edges over here. So FDA, okay, FDA have a connection with this one. Can you see it?
Yes, Pastor.
Uh-huh. So this is how the data looks like. So you put all of the actors here and then the relationship between them. FDA has got a relationship with this one. FDA has got a relationship with this one. But this is not the kind of data we have to feed to the software. These are all of the edges and these are the nodes. In fact, the node near important. The node is like the actors, okay? Like this one. Okay, these are the actors. So I say FDA, I'm going to put 1. Pharmacy council, I'll put 2. IT service providers, 3. Okay. These are just nominal values. So once I have that, I can now go ahead and run maybe my analysis. You see, well, after the analysis, this is the kind of result that I got. In fact, Gephi is going to give you this output. Okay. So Food and Drugs Authority, look at the degree. Look at 11. But look at IT service providers. That is 15. It is connected to almost every single one. Because we had 16. In fact, it's connected to everyone. We have 16 actors, including the IT service provider. Into Nifrima, he is connected to FDA, Pharmacy Council, every single one. So that makes him very powerful within it. Look at closeness. IT service provider to any other actor is just one step because every single one is connected to the IT service provider. And so I think we saw that somewhere here. Let me see if I can find it. Yeah, here. Look at this, the IT service provider, this guy. In the line, this color, no? Look, he's connected to this one. He's also connected to this one, connected to this. He's also connected to this and then connected to this one. So he's connected to every single one in the healthcare supply chain network. And that is what you are seeing over here. That, hey, closeness, centrality, this is perfect. This is perfect, perfect. And betweenness, centrality, that. Then, in fact, it be anywhere perfect, with the exception of the IT service providers. I just say, And then the rest, you see, the less powerful people within the healthcare supply chain are these people. Private hospitals and then private clinics. They are very powerful. And they even look at diagnostic centers. They are really powerful. Okay, when it comes to their relationships. They are crazy. But I'll share and say, I bind the enemy way now. Say, chip compound way and okay. So this is the kind of outputs that the software can provide to you. I don't want to save this. I don't want to save this one. And this, let me see if I can easily open this one for you to see what's happening in there. Okay, so this is the analysis, but of course I've executed this analysis already, and that's the reason why you see. So there's the table now me export here now over here. Okay, so you see the network structure. I didn't draw this, but the software did all of the drawing and everything, and is able to tell me the connections. Now this guy here, IT service provider, is connected to 15 people, so you can see it's connected to everyone. Okay, and it is just one step. If he needs to connect to FDA, IT people will get there straight. If they want to communicate with Pharmacy Council, just one step they are there. But if maybe this guy, see, the most powerful ones are the ones that are deepened, like this, and this guy. Okay, they are like more like a bit powerful than the rest, something like this. So this is how the whole thing is about. And so this is the how do you call it, the entire diagram we're seeing there. If you want to do some kind of editing to it, we have a lot of tools here to change the colors, just like what we have over here. And these are some few statistics. If you want to look at the average degree, it tells you what is it. The network diameter, it tells you what it is, like 2, which of course on the average it will take if you select one actor at random, if he wants to reach all of the other actors, like how many steps is it going to take on the average? Just 2 steps, he should be able to reach all of them, because every single actor is connected to the IT, and IT is connected to everyone. So moving from your end to IT is 1, from IT to that person is also 1, that is 2. That's the reason why you see these 2 here, and the others here, that with time you will get to appreciate them very well. But of course, we didn't discuss everything about social network analysis, because there are some things in there that myself I'm here to discover or understand. Okay, so I have to share the social network analysis 101 with you. And when you have some time and you develop interest in social network analysis, you may want to pick this one up and then maybe dig deeper to understand what is in there, because it's a deal. It's a deal. I don't want to change anything here. So any concern? Any concern? I don't know if you find social network analysis interesting, but in my case, I think it's very interesting. Hello?
Yeah, Pastor, it's interesting, but currently it's more theoretical to us. Anyway, to me.
Oh, okay. Yeah. The point is the theory is important. Imagine I brought you to the practical session, did a network analysis, and then told you that the diameter is maybe 2. What is the meaning of that 2? So the theory helps you to understand or appreciate what's happening over there, so that when the results are out, you're able to understand. Recently, I was asked to go and take some students one class on how to use, is it one of these statistical software? I don't know, is it Smart PLS or Israel or something? I've forgotten. One software. And what I was told was that they've already had one training on how to use SPSS to run some kind of analysis, structural models and everything. But then they wanted us to use a different software to teach them how to do it in addition to what they use SPSS for. In fact, I came out with a simple argument that instead of we teaching them how to use a different tool, why don't we teach them to understand the values that they are getting? Because the problem is not that they can't use SPSS to do the analysis. They can, because they've been taught. The problem now is when SPSS gives them an R squared of, let's say, 0.91, they don't understand what that 0.91 is. So I believe we need to take them back to the theory for them to understand what those things are. And once they understand, the next time they can use any software at all they want to. The software is just a tool you are clicking on. Once you click it, it gives you a result and that's it, you are good to go. So yeah, I understand. This is the first time you're seeing this, but I think you need a lot of time to digest the theory. Once you are done with the theory, then the practice will make sense, because the practical is needed a chairman. It's not anything really giddy. If you are doing research and you want to do social network analysis, you can even decide to give your data to someone to run the analysis. Once you have the data in a format like this, let's say, let me use the edges. Once you have your data in this one, source, one is FDA, and FDA is connected to all of these guys. Forget about the weight. The weight is just level of importance, but we are assuming that they are all on the same scale. This one is like undirected. We are not looking at any direction. Once we have the data in this format, that's all. If you send it to anybody who knows how to use the tool, they run the analysis and give you the output. And the output they will give you is this one. Okay. They just have to give you this one. And it is up to you to look at this to see that, if IT has got this, then it means IT is connected to everyone. You need to understand what these values are. Okay. But the values over here is not what's important at the moment. Take some time to digest the theory. Once you understand the theory, I think the rest will begin to make sense. Any other concern? Hello? Any concern?
I think we are good. Maybe
Okay.
we can go on break for a few minutes and then come and do the practical aspects from both the social network analysis and assessment analysis.
Yeah. So if we are unable to finish, I'll get you some materials. Okay. I think some time ago, I'm coming. Let me check. Let me check my download. It's like about 2 years or 3 years ago. Let me look at social network. I don't mean baby. I think I downloaded it, but I don't know. Baby, I'm the show all 102. Actually, like 2021. I used to have some kind of videos. I don't know where to find them, but anyways, if I get those videos, I'll share it with you, okay? So that as time goes on, you can pick it up and then maybe with time you can see what's happening in there. All right. Okay, so we are going to focus on this one, everything here. And can you see?
Yes.
Okay, so what we are doing over here is with respect to the data ingestion, the first one and the data cleaning. We have several approaches of getting data into our platform, and of which I want to believe that we've seen that a lot. Okay. Now, there are instances where the data you want to use for your analysis, you don't have them in some kind of Word document or any document. They can be found on a website. And like I mentioned yesterday, we have appropriate web scraping tools, of which popular one among them in Python is Beautiful Soup. So if you're interested, you may want to explore how to use Beautiful Soup to scrap that. But an easy way out is to use maybe a newspaper. Okay, so like we said, we have newspaper. If you don't have it, you have to install it. Okay, so that's the reason why I have this line of code over here for you. So let me call my kernel and let me see if it's this one. I want to see if you can install it directly from this point. Otherwise, I'll have to open the kernel and then use that. Okay, so let's say I don't know. This one, I want to see if you can install it directly from here so that you can always use that. Yeah, I think we can do that. But you can see from my end, it says that I already have those kind of packages that I'm trying to install. So of course, when you call an appender, the prompt, this one, you can install anything at all you want. So once you write pip install, any kind of tool you want to install, maybe tool name. Okay, when you put the name of the tool here, it's going to start to install. But of course, we don't have any tool, any library or whatsoever that is called a tool name. That is why. But we have one called newspaper. Okay. Okay. We have this product over there that you can install. So that is what I've done. I've tried to install mine. So I have it already. So if I try to call, but whatever thing I'm introducing, I'll remove them so that I can leave the rest of the codes for you. So once I'm done with the installation, I may want to pull it in. So for example, I can import the whole of newspaper like this. If I run this, I'm expecting this guy here to execute fine. And once it has been executed, you can see this. So I can now get into newspaper to see all of the items in there. In fact, we have a function called directory that tells us all of them, how do we call it? All of the methods, the I don't know how to put it, the properties of this particular guy or this library. So if I run the directory, you can see that we have something called article. We have article as exception. We have config. Newspo. All of these things are stuff that we can call. Okay, we have all of these things that we can call the parser, NLP, all of these things. But the one we are interested in is the article, because the article is the kind of let's say package. Should I call it package? Let me call it package for now. The kind of package we can use to scrap data from the website. Okay, and that's the reason why we are trying to get that one. So would you want to say that, okay, if I want to use the article, I can say that newspaper.article, okay, like this, before I pass my link to it. I don't want to do this. That is the reason why we are saying that, okay, instead of doing this, I can say from this newspaper, we want to import the only thing we are interested in, which is article. So of course, we are not interested in the other guys over there. All we are interested in is the article, because that's all we want to use. Okay. Now, what article does is the article tries to, let's say this, we have to pass some kind of link to it. Are you okay? We have to pass some kind of link to it. The link to the website where we want to scrap the kind of information we are interested in. So what I'm going to do now is whatever data I'm going to scrap, I'm going to keep it in a variable. So let's say I want to call this maybe web data like this, and my web data is going to be the article. Okay. Now, this article, where am I getting it from? All right. I have to put the entire link to that article over here. And once I have that, I'm able to pull the data over there and even download it. Okay. Once I'm done downloading, I can pass it to a format, or I can format it very well so that I get all of the text out of it. So for example, let's say I come to some website, any website where I can get a lot of information. So let me do some news, Al Jazeera. Okay, let me open this one. So you see this one here. This one is going to give me this kind of news, or the information, all of the information over here. So I want to grab this link, right? So when I grab this link, I can paste it here that, hey, I did what too much. I said, okay, so when I get this one, I can decide to run to see what is in web data. Of course, it is telling me that it is an object in this memory location, right? So once I have this guy here ready, the next thing I want to do is now to get it into my environment. And that is what this line of code is doing. This line of code is saying that once I have this object, I want to download it. And immediately I'm done downloading it, I can use it for anything at all that I want. So I'll come here to say that, okay, whatever object that I have over here, I want to download the kind of information from this particular link. So I can say this one here, I want to download. Okay, sorry. Once I have this, now I can call my web data again to see what kind of information I have in there. And you can see that I still have this kind of information. Okay, but then it was able to download the data that I'm interested in. All right. Now, because this guy here is an object has got several properties. Okay, the properties we have one where we are going to use to access all of the text. But let's look at something. Let's say I've downloaded the article now. Now let's say I'm interested in the text of this one. You see that it's giving me an empty text. Okay. Now the reason why it's giving me an empty text is that when it pulls the data is more like an HTML formatted kind of information. So I would want to pass this kind of data to web data. Okay, this is going to convert it to the kind of text we are interested in, and so therefore, if I try to push this one in here, it's able to pull the kind of information that I'm interested in. Okay, and also, do you understand that? So after I passed it, it was able to pull this kind of information from the website for me. So we're saying that this is one of the approaches by which we can pull any information at all from a given website. Not just this one. If I come to any website, let's say, let me come here and say CNN. I want to grab all of the information at this point. So I can grab this one, come here and see that I don't need this thing here. So I want to paste that one here so that I can pull all of the information over there to run my analysis. If I run this, it's able to pull all of the data on that particular website for me. But look at the data. So this is the first point. The first thing we wanted to do was to learn, that's the activity one, was to learn how to pull data from the website. But sadly, when we pull the data, we see a lot of issues with the data. Now, for example, look at this one here. Okay, this is an issue 2 and like we have 2 next lines. Do you understand? Look at what we have here, 2 next lines. These are all issues in our data that we need to clean. Okay, and that is what forms part of the second session or the second activity. So that is actually what's happening over here. At least you get to understand how every single thing in here is working. Any question about what's happening here? Yeah, you can come in.
That's a quick one. So if you have, let's
Okay.
say, a website that have comments, like a social
Okay.
media, the
Okay.
comments inside, would that pull it or to just pull the main data?
So this is going to pull every information on that website. And that is why I was saying that if you want to pull specifically just the comments, there is a better library called Beautiful Soup that allows you to even target the HTML tags.
Oh, okay.
You understand? It will allow you to target maybe if you go to the web like this, we are interested in paragraphs. So grab all of the information in every single paragraph you see. Grab all of the information you see under the comment section only. But this one here was to demonstrate to you that we can actually pull all information from a given website.
Okay, thanks.
Yeah, because this one here is not data engineering. Okay, this is what data engineers do. They connect to a web page or something, pull all of the information, clean it, store it in a warehouse like that. Then they give it to the analyst to run some analysis on it. Okay, but there is no data engineer 101 class. Okay, so that is actually what's happening here. At least you understand. In fact, if I decide to call this guy the web data, you can see it's still pointing me to a memory location, right? So I don't know if the directory is going to tell me all of this, but I'm not exactly sure. But if that is it, additional data, article, HTML, there are a lot of things over here that I haven't used before. Okay, but I think there are a lot of parameters over here you can use. This is the guy that we're calling the test. Okay, so that means if I call the web data right now, it now has all of these properties that I can call. So let me see. There's the download guy we used. I want to see something. I haven't tried it before, but I just want to give it a shot to see what kind of information I'll get. Let me call summary. Of course, I want to assume that if you call summary, it should give me, let's say, the summary portion of it if it has got that HTML tag. Okay. Let me see if it has that. No, it doesn't have that. Probably that's because of the kind of data coming from the website. Okay, but of course I know that there is a test in there that is going to pull all of the records in that particular website for me. Okay, so if you are trying to work with a new library and you don't really understand the kind of methods or functions in there, just try and then wrap it around the directory and it's going to give you a whole bunch of information about what that library is about. Okay, all right. So forget about this one here for now. Whatever thing we did is this guy. Any other thing involving the string here is with regard to cleaning the data. Okay. So once we have this one here, at least you understand what's happening. So we can forget about what I just deleted. Then I come here. Okay. So if I call, I haven't executed this one. If I call my article, of course, you know that this is where we were. Is anybody confused? Anybody confused? Hello, Christy.
I'm a little
Yes.
confused. Can you go
You're
over?
okay.
A little.
Okay, I want to know which part you couldn't get very well.
when you are trying to insert the web page and pulling it out, does it
Okay.
mean you have to indicate the article passy before
Okay, so let's do this.
Mm-hmm.
Okay, let's do this one. Okay. Let's say you are on a website like this and you found this information that you want to scrap. Do you see? You need all of this information here for some kind of analysis. Are we good?
Yes.
So how do you get it? Then we are saying that in Python, there is a library that allows you to connect to this one to pull all of the information here. One of them is newspaper. And then another one is also called Beautiful Soup. Okay. So over here, we are focusing on that of the newspaper. Okay. So I'm going to import newspaper. So I hope you understand what I've just done. This one. You understand this one?
Yes, please. I understand this one.
Okay, good. So when I run this one, this is going to import newspaper for me. But in newspaper, there are a lot of things in there. We have one specifically for pulling the data from the website. That is all we are interested in. So if I try to see all of the items in newspaper, I can write directory, dir for short. Then I put the newspaper in there to see what items are there for me to call. I can call any of these things. So for example, if I call version, I can do something like newspaper dot version. And that is going to tell me that this is it. You understand? Okay. I don't know if this is a method. Yeah, it's just an attribute. Okay. Now we have one called article. Okay. We have one called article. The article one is what we're using, getting all of our information from the website. So do you remember we did something like when we're doing pandas, we just did something like we import pandas, then we use it to connect to a data source.
Yeah.
The same thing applies to this one. So over here, there is one guy we call the article, which is this one. That's what we are going to use to grab the data from the website. So the first step that I'm going to do is to store the object. And it's supposed to be article. But because I have not imported the article, we can find it in newspaper. So I can now say newspaper, I need article. You know, article is coming from here.
Yeah.
Then it will ask you that, okay, if I do this, look at the argument that article takes. Article takes the URL, the link.
And the title.
Exactly. The title, they assign is like by default it is empty. The source URL by default is also empty. So if I decide to come again.
So you only the website is needed.
Exactly. That one is required, but these things are not required. So if I try to execute this one, you see that it says that missing one required positional argument, which is the URL. So I'll come here to say that this is the website I'm interested in. I'll grab all of the link and then I'll pass it here as the URL like this. Okay. I did a mistake. Okay. So now if I execute this one, I'm not going to get any error. See, everything has been executed successfully. Now this one here is just a connection to this website. That's all. It doesn't get you the data. Because if I call data, it just tell me that I have an object pointing to this memory location.
Okay.
So how do I get this data? I have to download it first. Okay, good. So I'll just do this download. This command here is going to download the article for me.
Okay.
You get it?
Yes.
Of course, if you want to store it, you can just do something like this, but it's just the same thing. Whenever I do this, it's going to replace the value in the data. So I don't need to say that, okay, I want to create a new data and it's equal to the original data downloaded. It's not really necessary. Okay. So now that I have this, I can run it. Now, this data has been downloaded. So if I call data, in fact, I should get my data, but there is a problem. If I run this, you see, it's still pointing me to a different memory location, giving me this object. Now, what's happening here? what is happening here is that I have downloaded the data, but the data is not in a format that I can use.
Okay.
So for example, if I try to see what is in data, the directory, or any other thing I can call, now this is telling me that I can call something called additional data, article HTML, I can call authors. In fact, let me see authors. I haven't used that before though, data.authors. Okay, it's empty because you couldn't find that kind of information over there. Do you understand? Good.
That means within the article, there's nothing like authors over there.
Exactly. It couldn't find
Okay.
it within that specified tag.
Okay.
Okay. All right. Because this one here uses XML to identify who authors are, what comments are, like
Okay.
all of those things. Okay, good. Now that I've downloaded it, you realize that there is another guy too. If I want to get the content of the article that I've downloaded here, how do I get the content? Now, if I look through anything I can call on this guy, you see there's one guy called test. This one here is going to give me the test that I have downloaded right now.
Yeah.
Okay, good. But let's call test on it to see what is going to happen. If I call data.test, it gives me an empty something. The reason being that the data that has been downloaded is not in a test format. It is like a bunch of tags, like this one. Let me show you some tags. You see what is happening here? This one.
Okay.
Bunch of these funny things. But then the test is embedded in this one. So we need to try and then tell this guy here that, hey, the data that I've downloaded, I'm not interested in XML or HTML or any format. I need you to pass it to a human readable format so that I can read the content. And that is what we do, data.pass.
Okay.
So we pass the data to a human readable form. Now that I've passed the data, if I call data.test, it is now able to get me the raw test in there.
Okay.
Yeah. So that is actually everything we've done here. But remember, we are doing newspaper.article because we did not call only the article. But if we want to call only the article, we can say that, okay, from newspaper, there is one guy called article, import it. Then I can take this one out. When I take this one out, I can now remove everything here because I have directly imported article. So I can use it as short as this. If I don't want to use this, but I want to import the whole of newspaper, I can now call newspaper dot the other guy I'm interested in. And this one here should work fine. The same thing. You get it?
Yes, sir.
Okay, sure.
Percy, one more.
Yes. Okay.
Assuming you want to get the picture, only the picture from the website.
Okay. So there is, like I'm saying, there's an advanced tool for that. But of course, that guy, this is there. Remember, we have, I hardly use this tool though. If I call this, you see that there are some images in here. This one. I think you can call this one to grab all of the images for you. But in fact, if I try to grab it, it can't render it over here. Jupyter, no, it can't render images like that images here.
It will come in a form.
Say be a police image when the image na beto her like that. No, it won't work that way.
But
so I don't know.
It will bring it to the link, right?
Yeah, it should pull any information related to the image for us.
Okay. Because I know you can use Python to pull an image or create an image. So I thought
yes.
it would try as well.
Oh, not for this one. Well, probably this one can do it, but like I'm saying, this is not a tool I'm used to. Beautiful Soup is better, but if you have to use Beautiful Soup for this one, it's the learning curve in here some way than this one. This is straightforward and simple.
Please, I understand. Let's go continue.
All right, sure. So any other person with a comments on this? Okay, so I think we'll keep coming back to maybe this file here to work with. Now the next thing is because we have all of these issues in there, okay, the \n and these things, it means our data is not clean. We need to try and then remove all of these funny things from it. Do you understand that? So maybe I can see that this is my data is equal to this. So I can come and then call data here to get my results. All right. So now I want you to understand that whatever thing we've done over here was to download and format the data. Okay. That is everything we're doing here. Now what we are going to do over here is to maybe clean the data a bit. Okay, so the data is stored in a variable called data. We can call it any name at all. We can decide to call this guy here article, and give this one here to article, call this one here article, call this one here also article. Then we'll call this one our data. Do you understand? So that if I call my data, I know that this is the kind of data I'm working with. I hope it's clear.
Yes, sir.
Okay, good. So whatever thing we've done takes us through everything that's happening over here. Of course, the next thing we are going to do is this guy here. To do this, we need to be working with strange kakra. Oh, strange kakra. But this is something we did in Python 101. But I don't know if you guys have forgotten, but I have some simple tutorial here on strange, okay, where I have this test here. If I want to convert all of this text here to lowercase, I can do just test dot lower. If I want to convert it to uppercase, I can do this. So I'm just going to be manipulating strange. Okay, if I want to replace something, I have to replace it with this, like anything. Okay, so just like, I don't know how to put it, but let's say I have test. Okay, and then the test is maybe hello world. Programming Python, like this. Okay, what if you want to convert this test here to lowercase? How would you do it? You can just call test.lower. Do you understand that?
Yeah.
And when you do this, we expect it to convert everything here to lowercase. And if you want to convert it to uppercase, you can just do test upper, and it converts everything here to uppercase. In addition, if you want to replace something, like you want to replace all H with V, so you can just say test dot maybe replace. I want to find all H. Maybe currently it is uppercase. Okay. Let me say I want to replace every single H with maybe a V. Python. Okay, yeah, that is true. But this H here is big, and then look at the Python, the small H here. It's only have V. Do you understand that?
Yeah.
So this is what you are seeing over here. I said, that is actually what is happening here. In fact, if you want to split the data, if you want to split the data, let me come here and cut this one. Let's say I have this data here and I want to split it so that hello will be alone, world will be alone, I am is also alone, programming is alone. I can just say test dot. I want to split this data based on space. Until when you see something and then you see space, split it for me. So if I decide to run this, you can see that I have hello, I have world here, I'm programming in Python. Say that if I want to see only hello, I can just do this. I'm sorry. Put 0 here and then it gives me only hello. I think we've done this one before, right? But check akra. Oh.
Pasty.
Yes, come in.
Should I wanted to find out if there's we have sentence case. Apart from the capital and the small, we can have a sentence case where beginning starts with capital and the rest starts with small.
Yeah, it should be there.
Okay.
It should be there. These are all of the things you can call. Capitalize, case, food, center, count, everything here you can call them.
Okay.
Thank you. So this is the split guide that I'm using. And this is the upper guide that I'm using. They are all here. So if you're interested, just wrap it around the directory and it will tell you every single thing in there. Okay. So I think this is something we've done before, and yeah. So that is actually what is happening here. Forget about this one here. We'll talk about it later. It is about you connecting to a different file and read the content. Just like pandas do read CSV, read this. So this is not coming from a library. This is coming from Python itself. Okay. So in trying to clean the data, okay, we are going to meet this kind of guy here. Now, let me explain to you what is actually happening here. Remember, first, we are going to have our data. In this case, we have article, isn't it? Okay, good. Now that we have our article, we want to try and then replace unnecessary anything that is making our data unclean. We want to work around it. But of course, the ones we are going to target now is punctuation, because we have a lot of punctuation in here. Do you understand that? All right. And this is how we can fix that. We can say that, hey, I have something like, in my article, I have comma here, I have dots here, all of these things. So I want to remove them. Okay. But how do we remove them? Okay, good. Now, this is what Python is saying that we should do. Python is saying that, okay, we should try and then translate the data. By trying to translate the data, it picks something we call translation table. Now, I'll show you what a translation table is. It is going to accept the translation table, and after the translation table, it's going to fuse it into my article. So it's going to like table, no, I don't know how to explain it. And I don't know why they call it table though, but okay, let me show you to you. So let me call this one table. And the table is, we can find that guy in strange. But let me show you that. str is the short for strange, okay? Now, let me call the directory for strange. And you find one guy, make trans, this guy. So this is the guy we are using. Do you see? So every single thing we are calling is not maybe say a free baby. It's built in Python. So we are going to call strange, okay? And when we call the strange, we are going to convert whatever data we are going to pass to it to, a translation table. And we are going to fuse that translation table in here. Now, on the normal, what we are supposed to be doing is that, hey, I want to pick my article, and then I want to translate this article by replacing all of the issues in my data. I don't know if I should start from this one, but anyways, we'll get to see that. Let me call strange itself. The reason why, I think yesterday I showed you the reason why we have this one here. We are supposed to be doing something like this. Article. I want to grab my article and then translate it. Okay. So it says that I'm going to remove all of the unnecessary information from it. Now, this is supposed to be my translation table. So if I do this, look at this. Translation, this is the table, okay? Replace each character in the string using given translation table. So do you understand that? Hello?
Yes, Pastor.
Yes. So we are going to pass something over here, and whatever information we pass here, the system will use it to replace all of the characters found in here. Okay? Okay, good. Now, I'll need the translation table. That is all that I am interested in. And what is the translation table? Translation table, as we call it with this guy. Okay? Now, let's forget about everything that's happening here, but that's how we call it. We have the make trans, and this is what we are going to do. In fact, let's look at what the make trans. Anyways, this is what we are looking for, what we are going to replace, and the last argument. Now, the last argument is like, hey, whenever you find all of these punctuation marks here, replace it, or we are going to create a translation table or a bunch of codes use that to translate the data that we have. If I'm going to run this one here and you see whatever kind of information I have. But then on the normal, I'm supposed to be creating a list over here to say that, hey, this list, or in fact, I can even create just a string. With this string, when you see comma, remove it. When you see full stop, remove it. When you see exclamation mark, at, pound, dollar, percentage, this, anything you see over here, remove it from the article that I have. And think all I'll do is to grab this one to say that, hey, this is my translation table. Then I'll put it here. Okay. But this one here, you can easily forget some of the punctuations. That is where this guy here becomes in handy. So I'm going to import string. Now, if I import string, let me look at the directory for string. Now, string has got something called punctuation. In fact, we have digits, we have this. Okay, let me call anything like string dot digits. Look at what it gives me from 0 to 9. Okay, string dot let me see, cap words. It gives me this string dot let me see, punctuation. Look at what it gives me. It gives me a list of punctuation marks. So instead of me typing all of this one by one, I can easily grab this, come here, and then say that my punctuation marks in any. What I say. So because I don't want to type all of these things now, that is what I'm trying to say that, hey, of course, I need to create a translation table. So I can now say that, hey, this is my table. Now come in the table needing Abeshaha, then I'm done. Okay. But open one, you can decide not to create a variable. You can come and then create it here. I'm going to, okay. I'm going to make a translation table. Do you understand that? Oh, now the number. Let's say typing in now. Make trans. So I'm going to make a translation table with this string here. So what am I going to do? The first two parameters, I'm not interested in them, but this time around, I'm interested in all punctuation marks. I'm interested in all punctuation marks. Let me now remove this one because I'm not interested in that. Now that I have this, the next thing I'll do is to execute this to see what is in my article. Okay. Do you see that? So this is my article, and you can see, say, all of the punctuation marks now. Or they say punctuation mark be a Once a punctuation mark be name, full stop, comma, those kind of things. Once a name. So what this guy here did was, he just picked the article, translate it by with this one, it removes all of the punctuation marks. But the funny thing is, you see, we have these guys also in there, which is making the data look a bit weird. Okay, but you see, this thing here is not part of the punctuation marks. So from our strange theory, we can just say dot replace. We can add replace to it. Otherwise, you can come down and say that, hey, my article is equal to article dot maybe replace. Okay, I want to replace anything /n. I want to replace it with this. That's all, and I'm done. Okay, so I want to say sign your money in Nefrim. That /n and you need Nefrim. But sometimes we don't want to go through this long route. We can just append it to this one like this, and this is going to do the magic. Okay, and then I'm breaking it down one by one for you to see that, okay, this guy here is actually my table. Okay, this guy here is my table. Then I put my table over here, then I do all of these things. I hope this one here is okay.
Yes.
Yeah.
Okay. Okay, good. Oh. Hey, no way. Oh, okay. Let me take this one here out. So we're trying to clean our code. Can anybody remember what we did? We said that we're going to import something, right? We're going to import string. because of just punctuation thing I imported string now. So when I come here, of course I have my data. So I need to clean my data up. Punctuation marks be so I can create my table here or my translation table. Do you understand? And how do we get the translation table? We call strange and say that we want to make a translation table. Are we good? Anybody remember what we did? Hello?
We translate.
You said we translate.
You
Okay,
type the translate.
So this is not the point where we are translating. Over here, I wanted to create the table. In fact, what you are talking about is we want to do the data dot, we want to translate it. Do you see?
Oh.
But I'm trying to, if you want us to put them together, that is fine. Okay, if you want us to put them together, we can just say that, hey, we want to translate it. But then we want to translate it by what? String dot make trans. Then the first argument, our second argument, and then all of our punctuation marks. So we can say string dot punctuation. Do you understand this? So that I don't need this one. But I usually want to break it down into various steps so that we can say that, hey, everything over here represents our table. Then I'll come and pass the table here. Now I say, I'm going to be fine. So I can now say that this is my data. Okay. So if I run my data, you can see that a or punctuation marks a few. Now, after running this data here, the next thing I want to do right here is that I want to remove this \n from it. And how do I do it? I can use the replace in string. Can just say replace. Wherever you see \n, replace it with empty something. Okay, so if I call this, you can see say some of these things need hiding. Okay, so that is what we've done so far.
Basti.
Okay. Yes, coming.
Please, yesterday you did something. You were saying the \n is like making it paragraph. You did something like that where it gave us paragraph.
Yeah, the / is like next page or next line.
Next line.
Yeah. And sad way no. To say from her to her. And as a no \n bisha na we number down.
So why do you have to remove it from? Why do you have to clean it? If it has a meaning to it.
No, so when we are doing analysis, we don't need that space. Yeah, fine.
Okay, so we don't even need the comma and the
No.
okay.
Sentiment analysis.
Okay. Yeah. Thank you.
So we have the data. We want to run sentiment analysis to see that whether this statement is positive or negative whatsoever.
Okay.
But if our data no, it will not help our analysis. So we need to remove them. Raw data for analysis.
All right. Understand.
Okay, sure. So now that we have this, let's ignore this one completely. We'll come back to it. How to open and then read the file. So that is what the activity one. Yes.
This quick one, the translation table. After the make trans, the two inverted commas up there. Is it always the case that you have to bring that to, or you can ignore one or at times? Or
well, I think those two guys, they are positional arguments. So you remember we were calling BBA function Bakubi, the article function. I remember that. You see, like the first thing is required. You need to put something there. The second thing is also required, and the third thing. So we have all of these arguments. But the first one, we don't have the kind of information to put here. The second one, we don't have. But the third one, we have. The third one is actually the kind of characters you want to remove. And that's the reason why we have to leave those two things empty.
Okay.
If you decide not to bring it and you pass something there, it will assume that the first thing now the about that's the first argument.
Okay.
So for example, if I create a function, let's say I want to define maybe play or maybe greet. Okay, and I say name and time like this. and I say that maybe time, I want to say something. Let me put result here and then say that I want to say time. Okay, then what should I do? 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 Okay, let's say I want to do something like let me put comma and then let me put a name here, something like this. Okay, now what I'm expecting is that if I do this, just something funny I'm doing. If I do something like James and I put something like afternoon, this, what are we expecting? Oh, I didn't print. Let me print the result. Okay, when I do this, it say on say or say, oh, let me add good. What's happening to this one? Hey, now send me a green. Hey, does anybody know what's happening to my machine? Good name, time. Hey. I don't understand what's happening. Okay, let's say I want to do maybe whatever information you bring in. I should say, good afternoon, James. Do you understand? Now, this is the positional argument is that the first one should be the person's name. The second one should be the time. Now, assuming I decide not to bring this one, or, okay, I decide not to bring the first one, but I run this. Look at what happens. But what if I say that I want to do something great, but then the first argument is empty, but the second one is morning? Do you see this? So it says good morning. Do you understand? Because this is empty. So there is an empty something over here. But if I put something over here, like James, it will now say maybe something, good morning. Then the name should come, James. Do you understand that? I don't know if I'm making sense. Hello?
You are.
The person who was asking the question. Okay. So it's
Yes,
an
yes,
issue
please.
of it's an issue of positional argument. If you don't have any value for this one, you can just leave it empty, just like what we have here. Okay. So
Thank you very much.
right, sure. I don't know why this is not giving me all of the information that is needed. But, I don't know. But if you read the information over here, those arguments are kind of Unicode values, characters, and those kind of things of which you may not be interested. So, like, I just wanted to know the method signature so that I would know that, okay, this one is taking this, and that. Okay, that's it. So, now that we have this one, I think that brings us to the end of the first activity. That is this. Let's ignore this one completely. So the first thing was to understand how to grab information from, let's say, the website. Now, the second thing here is we wanted to do some kind of emotional analysis, okay? So with that emotions, we have a file with a lot of information in there, and this is the file. And this is the information in that file. We now want to analyze this data here to tell whether this statement here, the person was happy or the person was not happy about whatever thing is happening here. And so we have to grab the content of that file. Do you understand that? Okay, now let's forget whatever thing is happening over here, okay? Is it the first one or the second one? I think it's the second one. Okay. So this is going to be something like activity 2. Now, activity 2 is saying that we want to grab some kind of information, this file. We want to grab this file. And when we grab it, we want to read the content of this file. So let's say that, let's call this guy here content. So our file content, do you have any idea how to read content from a file? Of course, pandas is going to be, maybe when you import pandas, maybe as PD or something, then you can say pandas.read CSV. Okay, then you pass the link to it. There's the read Excel, those kind of things. But what if we are not using pandas, but want to use raw Python? Then of course there is a function called open. Now, when you call open, it tells you that you have to supply the name of the file. Okay, open file and return the stream. Okay, so this is how it's. This is also going to give you an example of how to read the file. Oh, okay, wait, don't want my example. Anyways, but this is the first thing is the name of the file, and you can see every other thing has got default values. So even if you don't pass them, it's fine. So we are going to put the name of the file here. What is the name of the file? It is called file.txt. All right. Now I'll explain something to you. If I call content, look at it. It's pointing me to this kind of object, but this is not my interest. I want to do this and then read the content of this particular file. Okay, and that's the reason why you saw the .read guy over there. This one. That's why you saw this guy here. So we have this dot maybe read. Okay. Otherwise, you can just say maybe content dot read like that. But I don't know why we want to do this. So if I try to read the content from this particular file, this one, and it tells me that this is the content. Okay, so this is how we are able to read content of a file. Okay, for now, we haven't started the sentiment analysis. We are looking at how to pull the data in before we even progress to looking at how to run some kind of analysis on our data. So now that we have our data, the next thing we have to do is to try and then transform it. And from our slide, we said, normally we may want to convert all of our data to either uppercase or lowercase, just to standardize the data, okay? And by now, you know how to convert data to lowercase, isn't it? I hope you know.
Yes, please.
So once you do this and I write content, I'm expecting to get all in lowercase. So that is actually what is happening. Of course, you know that if I want to remove all of these things, exclamation marks and the dots and everything, you know how I can do it, right? I can use translation table to remove all of these things. I can also use the replace. For example, I can do this. After converting it to lowercase, I can replace or maybe at with this one. Okay. Oh, what happened? Okay, I haven't called the content. Okay, on say at nephew. So if I want to replace them, this is how I can do it. But doing this one by one, it can also be annoying. That is the reason why we tend to use the translation tables, not BBR content. Okay. So we'll try to convert it to lowercase. Then we use our translation table to do all of these things. But of course, I don't want to write this code again. Let me just copy it and then come here because as a mature, I'm a break. Where is it? I want to clean my data. So this is my content, and this guy here is also my content. But of course, this is going to blow up because I haven't called the string. Do you see? Oh, okay, it's here. Once I have this guy up here, I can have this guy also ready. Who is confused about the steps, what we've done so far? Are we all good?
Yes, Pastor.
Okay, good. So if I call content, you see that all of frame. Instead of me using dot replace, no, frame. and I don't have \n in there. And yes, and come the best also say any \n so and fine free. So I think for this one, I don't know if I wanted to go. Okay, over here, I actually did some real kind of analysis. Okay, so after translating the data or cleaning it, remember we said we have several ways of tokenizing our data. We can decide to split it because I've shown you how the split works. Once I'm done with the split, of course, I'll get a lot of tokens. So I'm going to select the kind of tokens that I'm interested in, and the ones that I'm not interested in, meaning in idea free. Are we good on that? Okay. So let's come here. Okay. Is it this one, right? Okay, good. I'm not interested in this, but we just want to tokenize our data to say that, hey, I need this one standing alone, this alone, this alone, this alone. Okay. And that is going to be our tokenization. So I'm going to say that for the content, I want to say my content dot split. I want to split it with what? Space like this. Now that I've done this, I know my data is going to look like something like this for me. Okay, good. So this is the data that I'm going to analyze. Okay, this is the data that I'm going to analyze. But remember, this is our content. Okay. The next thing we are going to do is that we have another file because we are going to analyze the content na papers is here now as against another content, emotions. Okay, so this is the emotions. We have all of these emotions like victimized means cheated, accused means this means that, this means that, all of these things. So we have to open this file and then read the content. Do you understand? We need to grab all of these things. And that is what we're doing here. That if I want to read the content like line by line, line by line, we have several ways of doing it, but we tend to use a very simple approach for doing that. So for example, we have the with keyword, okay, where we use with open, or it means that I said, so long as this guy here is open, keep on going through to grab all of the data that is in there. If you come here, you see that there is one here, we need it. When we come here, we need it. And mind you, when we grab all of these things, we need to clean the data, okay? So if you look at the code that have been written, we're cleaning the data. So if you come here, we open our file like this. Once you open it, this thing here is represented. By now, you know the alias. So this one here is representing each one, each line. This one. This is one line, another line, another line, another line. So once we have the line, then we are able to go through each of the lines. Then we'll grab all of this content. I'm going to show to you why we even have to go through all of this stress in order to clean our data. So, Mpacho, hold on. Yeah, hello. Sorry. Okay. So let's try and then get this one. So we are going to first, in fact, we're supposed to open maybe our file, and of course our file is called emotions.txt. Okay. But we are saying that so long as this file here is open, we want to do something. Okay. And that is why we start with the with as we are opening this one as maybe every single line. What do we want to do? Let's say I want to print the line. Oh, emotions.oh. Okay. Now you see what is happening over here. It's saying that each line is like an object. Do you see that? So that is why I told you that I'm going to explain to you why we even have to loop through this particular object here to get all of the data in them. Now, if I say maybe let's say for row in each of the lines, we want to print maybe row. Now you can see what is happening over here. Now the reason why you see all of these spaces, I said from this space, this one here to this one, as a space, big, you know, is because of there's like a backslash n over there, like a backslash n. That is why I'm out. So if you try to remove it, I don't know if anybody doesn't understand anything, but do you understand what's happening on this line? Hello? You understand what's happening on that line?
Basti,
Yes, come in.
please, it means we are using the content of the emotion test.
Exactly. So this is what we are saying. When we call the content, on says you're breaking content down to this. Okay.
Yes.
Now, what is the meaning of love? Love is associated to a certain emotion. Python is associated with a certain emotion. Maybe bugs is also associated with a certain emotion. So what we are going to do is that when we identify this word here, let's say here, then the emotion attached to it is this one. So we are going to analyze how many love did we like find in this data that we have. Do you understand?
Yeah.
So this is our data, and this is the meaning of each of the records. So we want to grab all of these things. Now you analyze it and say, okay, oh, this one means this one means that. So first, now we are trying to open the emotions file. Now you're grabbing all of the data out. So that's what we are trying to do over here. But in trying to do it, it's supposed to be as short as this one. But in trying to do it, look at here. We have all of these things here. We are trying to remove plenty things. And say I'm a sure say ahano. One say lines as a big B about them. Now let me show you. Let's say this is my row, and I want to say maybe row dot. I want to replace any backslash n or any next line with nothing. If I print row, I want to say those spaces in a frame. Do you get it? So we'll try and then say that, oh, okay, we have some comma over here. So I want to also remove that comma as well. So whenever I find any comma, remove it. What is that? Strange object has nothing. Oh, replace. Assembly included. I want to say e comma and so flow.
Yeah.
Then I also want to remove this one. So I'm trying to clean this data so that I can grab this one and this one. So that if I find anything here, now they are match away. Something like that. So that's all we are trying to do over there. Nothing really fancy. Then I'll come here and then say that, hey, I want to replace any single quote that I find in this one with this. I'm say single quote in a frame. Now I come in and say to a way. So with this one, I can split my data based on this, just like what we have here. So see, I'm
But the
replacing my
columns doesn't matter, right? With this one, the columns doesn't matter.
No, the colon. No. So if I decide to remove the colon, if I remove this colon, I won't know that this
Okay,
word
that's separate
victimized
them.
means exactly. So I want to split this one here into two. Now I want to say, oh, wherever I see victimized, it means cheated. If I see accused, it means cheated. If I see this, it means this. That is why I didn't remove it. Okay. But I understand. It will take you some time to digest this one because maybe this is your first time doing this. Okay. So when I'm done with this, I try to split the data based on this one here and this one here. Okay. Now, when I split it, I try to get the first value. Once I split the data, I use indexes. Like index 0 is this, index 1 is this. So when we find the index 0 in the test list, list, data. If we find it in there, then we create emotions and then append it to it. So this is what I mean. Okay. Let's say that I want to pick my row. Okay. Then I want to split it by this. So now let me print the row. At least you get to know what is in row. On how I know. This is victimized. Need any cheated. Accused. Need any. We into any. Do you see what's happening? So the best thing I can do is to grab this. If I grab this pet, na my say we ma. Into woman, na my add cheated. We are na my kind say cheated in saying. So that I can plot to see that hey, for this statement, we cheated near 2, we are 5, we are 6. Do you see? I don't know. It seems it sounds a bit complex to you, but I think with time you'll get it. And this is here, we are expecting that the words ne wahano and kebin pie ha. Oh, ebin pie ha. And this a pie ha penny a pick the emotion attached to that word no. Oh, this a castle will be annoying that the emotion is angry. Castle animated that the emotion is maybe happy like that. So we need the word. All I have to do is that if I grab the first one, which is 0, instead the victimized and accused number. If I grab 1 at the emotions number. So what am I interested in? I'm interested in the 0 ones. But of course, you see, there are some. If I try to do this, once a space be a word we in him. But we say in the space in him. So we'll try and then remove that kind of space. And that's the reason why you see that trim, the strip, this one. So when we do this, we strip all empty spaces around it. What do I say? So when I come here, I'm going to pick this row. Then I'll trim all of the empty spaces around it. So I'll just do this. And I say, let me even print this one, but then I want to strip all of those things. Now share how it will be arranged. Once you see everything has been aligned, because all empty spaces no if you. So I can say that clean say clean test, just anything, however you may want to call it. So you can say that if this clean test, they will victimize an asset and then if the clean test, we can find this clean test in this one, in the content, okay? If we can find whatever word at the moment in this data now, in content, what do we want to do? We want to put this clean word, the associated emotion, we want to keep it somewhere. So let me create a variable here and then call it emotions. Okay. Now this is emotions, empty. BBA is here. So for example, if I try to call emotions, I want to say empty BBA. Okay. Now let me do this and say that, okay, if this clean test can be found in the list of content that I have, let me remove this. If this clean test can be found in the list of content, then what do I want to do? I want to grab these emotions. Then I'll assign something to it, which is append. What do I want to append to this one? I want to append the associated emotion. Do you understand that? I want to append the associated emotion here. Do you see? Hello?
Yes,
Hello?
Pastor, we have.
Yes, I want to append the associated emotion here, not the word itself. So, Enka, all I will do is that I will go and grab my row. But which row? Am I interested in 1 or 0? Remember, 0 is the word that we are looking for over here. And Tinka we cry no me pa me mfa ma hakra. O de ma me mfa be sha. I mean clean test no cry frame. Okay? So when I grab index 0, I want to check if index 0 is in my content. If it is in my content, what do I want to do? I want to grab the emotion associated with this index 0. So over here, I'll just put the 1 over there. Because if I put 0, it will be putting the same value in here. But if I put 1, it will be putting the associated emotion here. But of course, I want to strip it. Send a bear if there is any Yawabiana empire. So look at this. You see, I have sad 2 times. So for this content, 2 means sad. 2 words over here mean sad. And 1 means loved and 1 means fearful. Do you understand? So this is my emotions. Then we use the counter to count how many of these values here. If we want to count sad, sad near saying a 2, loved you're saying a 1, fearful you're saying a 1. We are near plotted. And that's the reason why when you come here, man plotted. Anyways, so that is why I called the counter over here. Okay, I called my counter. Now Juma say obe pick the data no kind. When you kind we are good to go. All right. So let's just call collection and then we'll call the counter on it. So I can just come here and see that over here I want to import collections. Then I can see that my emotions should be equal to collections.counter. Okay, because I don't want to import the counter guy. Otherwise, I can say from collections import counter. Now my use to counter. So there are several ways of doing this exact thing. So I want to count what? Emotions. Now, if I call emotions, look at what happens. It tells me that mpacho sad, loved, fearful, so let's look at the directory here. Now you can see a lot of things that we can call. We can call keys. We can call items. We can call something like everything here. We can call values. Do you understand that? So we can get the keys and then we can also get the values. So that is what you see over here. Oh, I did one. I think it's here. Yeah. So we can call the keys on it and then we can also call the values on it. And that is going to help us know that the patch of sadness no and a way so say. Okay. So so let's say my keys is equal to what? Emotions dot keys. Then my values is equal to emotions dot values. Of course, you know what is in emotions. Okay, emotions is this. These are the keys and these are the values. So right now, if I call the keys, I'm getting sad, loved, and fearful. If I call values, I'm getting 2, 1, 1. Okay, so it means that for the data near one, emotions a woman, sadness a woman say, happy a woman say, and a fearful so a woman say. Now that I have this, I may want to use Matplotlib to plot this data here. Okay, so let me import it over here instead of going up there. So I can say matplotlib dot pyplot. I'm importing in April. So I want to import matplotlib.pyplot as maybe PLT or something. Then I can use PLT dot. I want to use just a very simple bar something. Okay. So with the bar, I can put maybe keys and I can put the values here. I hardly use this thing here. Yeah. So you can see sadness is 2, loved is 1, fearful is also 1. So this is everything that is happening over here. Any side which is confusing, you can bring it up there, we address it. Christy, are we good on this one?
We are
Yes.
good, but I wanted to find out. So always you have to get a file that contains the emotions or whatever you want to compare with what is in your article, right?
It's not always a file. Sometimes you can get it through an API. So there can be an organization that have compiled all of these things for you. That is, if you want to do emotional analysis kind of maybe or the kind of data you have, you want to run emotional analysis on it. But mostly you may be running sentiment analysis. Okay, sentiment analysis, you don't need this one. You can use Veda or TestBlock to run the analysis straight. You don't need any of these things. This one here is there for you to understand that there is something called emotional analysis. So if you have data and then you want to look at people's emotions towards a given thing, maybe an another Abema speech be, and some more you want to analyze the Ghana for emotions, no, whether it's hateful or they love it or they are sad about it. Yeah. So that is actually what's.
Please, so I want to find out. Assuming I want to analyze, as you are saying, another speech.
Okay.
That would I need this one, or there's a particular page I can get the emotional to just fix, like how we attract the website from other.
Okay, so for now, yes, I understand. So for now, I don't really know a website that has actually compiled this one. So before we did this one, I did a quick search, and the search was this one. This is the result that I got. As Obi Atenase no aye, and I mean to me use what I say.
I can also create my own, right?
You can create your own, but it can be very difficult to do. It looks like so the whole word, every single word you are finding the emotion attached to that word.
Yeah. But I can customize one to suit our Ghanaian context in order to analyze maybe a politician's speech, right?
Exactly, you can do that. All you need to do is to do something like this and you are good. But I want to believe that there is an API that has actually assigned maybe emotions to us. Let me see where to maybe emotion API. I don't know if there is something like that, but I think it's there. Do you see this one? Text to emotion API. Do you see?
Yes.
But you have to pay to use the API.
Oh.
Yeah, they have a free. They have a free plan. They have a free plan, so you can subscribe to the free one. See, so a live demo, you can check myself. I haven't seen this. This is my first time seeing this one. So you just have to go to the documentation to see maybe how they call we have a register. So we need that. Okay. Live demo. So they tell you the kind of endpoint you have to use. So you can see this is the endpoint, asset.api player blah 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 blah. You just call it and it's able to return the emotion attached to that word for you. So this is something you can easily, I think they've done a very great job. So if you're interested, you may want to dig it up. But me sure saying you will API over there. Emotion analysis API. You see this one. This one is also there. You can easily connect it. You see this one. Input some tests. After living abroad for such a long time, seeing my family was the best present I could have ever wished for. And this is the result they are giving you. That the emotion detected is joy. Emotion score, joy is this, surprise. I think this is really great. So those of you who want to do something emotional, emotional analysis in your thesis or something, you can just come here. I think the pricing, pay as you go. Just a book what is this? 2,000 per month. What is this 2,000? 0. Oh, okay. You get to analyze about 2,000 data points every single month. If you want extra, you pay $0.002 dollars. And if you want pro, it is $19 per month. So this is not bad. This is not bad. So guys, let me share this link here with you. When you have time, those who want to do emotional something, you can. I'm putting it in the chat, so you can check it out. I think that this API is really interesting. So the president of Ghana does not really care about what's going on in in educational maybe sector. So this can be a statement, okay? So apart from you running sentiment analysis to find out that, oh, this statement is positive or negative, you can also run emotional analysis on it to see that, oh, they are not happy, they are sad, they are angry, they are this, they are that. So let me analyze this statement to see what the output will be. And yeah, this is saying that the emotion identify the surprise. And of course, you can also build your own AI model to do this one here for you. So in fact, this can be your project work as well. You may want to build your own emotional analysis AI sort of something. So when you build your AI and then someone gives it a statement, you should be able to analyze it to say that the person is surprised, angry, or this, provided you get the data to train the model. I think this will be a very nice project, you know. And will be your DigiScan. Until we are also beating DigiScan. So I think this is really a cool project. This is like, honestly, is a cool project. It's a cool project. All right, so that is that for this one. But over here, this is the one we had. We didn't have money to buy the API, so and assuming you want to use this API and you are struggling on how to use it, you can get in touch, okay? Because if you haven't worked with API before, it can be some way. Okay, no, we are not interested in AWS. We want login with Amazon, no. Yeah, category, recommendation, basic plan, and some API key. This one you need to register. Yeah, once you create an account, see documentation. This is the guy I'm interested in. So I can hit it. And guys. I think these people also do sentiment analysis, and so I think you guys will find this website here really helpful. You'll find it really helpful. So you can come here and then check them out. Just come here and then check them out. I think you're going to. So you can create an account with them. Rapid API Markets. So once you create an account with them, you are good to go. Yeah. And I'm sure there are some other, you see this one too. This is giving you a list of APIs out there that you can use for emotional analysis. Okay. So so all of these companies are doing some comprehend. Yeah. And we have this one out there and NLP1 AI. So let me share this one here too with you. These are all AIs that you can use. I don't know if you understand what I'm saying.
Yes, please, you do.
Yeah, sure. So that is that for this one. Okay, so this is showing you how to run that. And see, if you have some test and you want to run emotional analysis data on it, you just have to do that. Call this guy here, and you are good. You should be able to tell the public that, hey, Ghanaians are sad, or they love the statement you made, or like this. And I think this one here will be very good for the politicians. You know, if you are this kind of data analyst and you tell a politician that you can tell whether or not Ghanaians are happy about their speech or not, all you have to learn in addition to this skill is web scraping. I use Beautiful Soup or post a statement. Now go to the comment section, get all of the data and then run this analysis on it. Report back to that politician that, hey, this thing that you said, Ghanaians are not happy with it. So you recommend ABC. I think that would be like an interesting thing to work on. Okay. So our time is up. I don't know, but we have some activities here that helps us to do sentiment analysis. But the sentiment analysis any asa. Now can data cleaning. So I'll share this one here with you, but assuming you have some day within the week, someday within the weekend, you want us to go through this one step by step and this one too step by step. Of course, I'll be available. So once you hit me up, we can quickly do that. But for now, I think we are able to go through activity 1 and activity 2, and I think that should be fine for now. Any questions, suggestions, recommendations, anything of that sort before we end the session, because we've gone past time now. Hello.
Yeah, that's please. If it would it be possible to share the project, the entire project with us?
Yes,
So
sure.
that
I'll share
so that we
this thing
can
here
go through the code
with
and
you, so that when you
Okay.
open it, you can have access to everything. Yeah.
All right. Okay,
Okay.
sure. Thank you.
But if you're going through and there is something you don't understand, you can hit me up. Then we'll resolve it.
All right.
Okay. All right. Thank you very much.
All right. Thank you, Sebastian.